Well, good morning, good afternoon, good evening, wherever you are in the world. Welcome to the DB2 Night Show, episode number 216, the season number 10 grand finale. I'm your host, Scott Hayes, an entrepreneur, IBM Gold consultant, and lifetime IBM champion. Our special guest today is Pavel Sustr. You can follow him on Twitter at Pavel_Sustr. Today's topic, DB2 LUW Problem Determination Class, our Season 10 finale. Pavel, how are you today?
Hello, Scott. I'm doing well. How are you?
I'm fabulous. It's going to be a wonderful weekend. And you told me the weather's going to be awesome in Toronto as well. What are you going to do this weekend?
I'll probably go for a swim to Lake Ontario. No, just kidding. It's not that warm, but yeah, it's going to be beautiful. Yeah, so probably barbecue outside, the usual.
Barbecue? You mean folks that live in Canada know about barbecue? I thought that was a Texas thing.
We like to have fun too, you know?
All right. I guess we don't have a monopoly on barbecuing. Other people can do it. What are you going to barbecue? Hot dogs? Hamburgers?
I was thinking about some steaks, to be honest, and maybe some chicken. So yeah, it's still to be decided. I like to improvise, and you will see that throughout the presentation.
Okay. Well, good. Improvising is good. DB2 Night Show is a show for the community. Make sure you're following the DB2 Night Show on Twitter. If you do any tweeting, mention at DB2 Night Show or Pavel's handle there. And there's a LinkedIn group that you're welcome to join for news and updates about the show. The show disclaimers, etc. Let's see. I don't know. We're not going to read this today. We're recording this. Trademarks and copyrights and mind your manners and all that stuff. Pavel will have his own disclaimers, I'm sure. Tonight's show, some quick announcements. Pavel's problem determination class. We're going to take our commercial break around the 30-minute mark today, and then we're going to take bio breaks for your bathroom, restroom, toilet at the top of the hour. So we'll have a couple of bio breaks during this 3-hour show, and then we'll ask our audience polling questions, and we'll wrap up like we always do. So, upcoming shows. Hey, guess what? Zenda Season 10. So this summer you get to watch replays. And I'm told there will be a Season 11 of the show. And I'm told that Martin Hubel will be hosting it and running it. That is what the owner of DBI Software tells me. So pay attention to social media and the show homepage for details. That'll probably start up this fall. Congratulations to Paul Baranowski with HSBC in Arlington Heights, Illinois. He's the winner of a $25 Amazon gift certificate. He was in the audience of show number 215, which was breaking news from the IBM Canada lab on DB2 version 11.5. Kelly Roger from the IBM lab was our guest during that show. If you want to learn about what's new in 11.5, go watch that replay. And here's your giggle of the day, dog alarm modes. Got your doorbell, burglary, serial killer, and cheese wrapper. Paying attention to the cheese wrapper. I thought a dog alarm modes was kind of fun because when you think about problem determination, it's often reacting that some kind of alarm has gone off. So there's your dogs. By the way, in the state of the DB2 universe, worldwide study, dogs were more popular than any other pet with the DB2 community. Dogs win. And that takes us to Pavel and his amazing class. Thank you so much for providing this class to our worldwide audience, Pavel. Got a huge audience
problem.
today.
you for inviting me.
I'm going to click a button here and make you our presenter.
Okay.
And you should have a little thing popping up on your screen saying show your screen.
So you should be able to see my screen now, hopefully.
Oh, I still had Paul Bird's picture on there. Shame on me. Here we are. Looks like problem determination troubleshooting workshop. You're in slide deck mode, not slideshow mode. You have multiple screens.
Okay.
Are you a multiple monitor type? There you go. Now we're in slideshow mode.
Oh, is that right?
Now we're back to slide mode.
Okay, so it's probably because of some lag.
Okay,
now
there you are.
Full screen.
Full screen.
Perfect.
You got it.
Okay, excellent. Thank you very much, Scott, for the introduction, and thank you everybody for joining me from all around the world. I appreciate taking your time off your busy schedules. Today we have a packed agenda. If you have seen the description of the seminar, I will explain a lot of things about traps, data corruption, hangs, performance problem determination. I have about 155 slides and only 3 hours. So part of the presentation should have been demos, which I will postpone until the end, but don't you worry. If everything that I will be demoing is also on the slides, so this is just pretty much a live proof that what's on the slides is actually correct, and it's live, and it hasn't been messed around with. That said, moving on to the first part of my seminar, we need to start with some theory before we get to details. So here we go. Throughout the slides, you might hear me using some weird terms such as Viper, Viper 2, Galileo, and stuff like that. This is just for your reference. This is the history of our releases, starting with 9.1 Viper, 9.5 Viper 2, 9.7 Cobra, 9.8 didn't have any cool name. It was just called DB2 PureScale feature. 10.1 was called Galileo, 10.5 was Kepler, and 11.1, again, a little bit no code name, 11.1 with blue acceleration. So that's just for your reference. When we get into our problem determination mode, the most important thing that I always teach to others is you need to determine where the problem is occurring. In other words, you need to narrow down the scope. This is a problem determination decision tree that I have created over the years. It's just my way. Your tree might be different, but the bottom line of this slide is that I'm trying to narrow down the scope of the problem. And I usually start with the top left corner, which is the server machine and the operating system. Then I looked at the instance, at the database level, at the application level, and I tried to determine whether the problem is happening on the client or on the server. And usually most of the problems that I deal with fall into the 3 categories that are listed at the bottom of the slide. So we are usually talking about a crash, about some kind of an outage. We are talking about a hang or a performance problem, and I purposely put them into the same category because you will see throughout the slides that the basic methodology for troubleshooting these 2 kinds of problems is the same. Or we might be talking about an SQL code error. DB2 or IBM has come up with a list of data, or with checklists of data that we recommend to gather for specific types of problems. This is not a very well-known document, so I really encourage you to follow this link, have a look, and see what's there. I only got a question about this link yesterday, and that was from an IBMer, so obviously we don't market this link strongly enough. When you go to that page, you will see a list of usual problems and what kind of data needs to be collected for this problem before you open a ticket with IBM. So again, I recommend you have a look at this page. The most interesting stuff, detailed stuff, would be usually the Hank problem determination and optimizer problem determination. They're very well described, and it shows you, it gives you an idea about the data that you should be gathering. Now, before we get into some low-level stuff and look at dumps in DB2Diag.log, you need to understand that some of the dumps and some of the messages that we produce in our diagnostic logs are in hexadecimal format. When you're talking hex, you need to understand which machine, which type of machine you're on, because the byte ordering for hex dumps might not be intuitive. It may not be what you're expecting. Now, the industry standard these days is little NDN. Little NDN, it means that the most important byte, the most significant byte, starts at the little end of that number. So when you have a number that is supposed to look like hex 1, 2, 3, 4, 5, 6, 7, 8, in little NDN, you would start from the right and you would read 1, 2, 3, 4, 5, 6, 7, 8. So keep that in mind when reading diagnostic logs and hexadecimal dumps. Some error messages, typically return codes and raw dumps, may not be ordered in the sequence that you would expect it, not in the native human readable sequence. The most important place where you would look for diagnostic data in DB2 is the DB2 Diagnostic Directory. It's determined by the DBM config called DIAK path, and and that directory contains the diagnostic log, the administration notification log, any trap files, dump files, typically core files, flight recorders or event recorders. Any diagnostic data should be located in the diagnostic directory. If it's not, please call IBM and have us fix that. We do intend this directory to be the ultimate location for all of our diagnostic data. In purescale, we also have a configuration parameter called CF DIAK path, which is exactly the same thing for the CF facility. There's a little bit of misunderstanding. Some people call it cluster facility, others call it cache facility. I call it CF. I don't know which one is wrong, which one is right, or which one is wrong. I just call it CF. CF is the kind of the high availability manager for purescale. You know, the thing that oversees your purescale members and contains all shared structures that are, you know, present or visible to all members in the purescale system. So CF DIAK path has the CF-diag.log, CF dumps, CF diagnostic specific files, and port files as well for the CF. The location, the default location of the DB2 diagnostic directory is your instance home /sqlib/db2dump. On Windows, it's in this directory, so don't be surprised it's slightly different. In purescale, the default directory is exactly the same. It's sqlib/db2dump. However, the difference is that in purescale, we will see subdirectories under db2dump, and they will be numbered. So we will have diag 0000 for member 0, diag 1 for member 1, up till diag 128 if you have 128 members in purescale. Sorry, 127 I should have said. 128 and 129 are just backup directories for the CF. Now, in the DB2 diagnostic log, you will see messages written in English. The primary purpose for the DB2 diagnostic log is to provide enough information for IBM service, for IBM technical support. But that does not prevent you from having a look at the file and trying to understand. And I'll do my best during the presentation to explain some internals about DB2Diag.log. This file will never be translated into any other language, as far as I know. For localized translations, we have the administration notification log, the NFI, as we call it. So that file is supposed to be a quick reference for the DBA to have a look at what's happening on the system, and those messages will be are translated into the local language of the server. The level of debugging or producing information is controlled by yet another configuration parameter. It's a DBM configuration parameter. It's called DIAK level. The default DIAK level is 3, which means that we will dump all errors and warnings. Now, some of you may have played with other DIAK levels. I recommend not to. Certainly don't increase it to 4. That's my main recommendation. DIAK level 4 will, and I repeat, will cause performance problems if there's too much logging going on. It's not meant to be used in production environments. So if you are running production, please switch it to the default or lower. So default is 3 or lower. Okay. Here's an example entry of DB2 Diag.log. I think most of you are familiar with this format, so I'm not going to spend too much time. What we have is a timestamp, process ID and thread ID information, level, whether it's an error or warning or whatnot. We will see the process name. We will see the application handle that's caused the issue, if there's an application associated. And then we'll see the function that produced the error. So this is the actual place in our code that produced the error, and here's the function. SQLB is a prefix. SMS do container operation, that's something that's supposed to be user-friendly or developer-friendly. So in this case, you can probably take a guess that we are doing a container operation on an SMS table space. And this probe number that you see, 815, it denotes the place in that function, do container operation, that had produced this error. And the final part is the error text that explains what happened and why it happened. Some of you may have noticed that the timestamp is appended with a weird prefix, or sorry, postfix, I should say, -300. What does that mean? This is the number of minutes that's the difference between the current time, the server time, and GMT. So in this case, we are 300 minutes behind GMT. So if my math is correct, 300 minutes is 5 hours. So this is GMT -5. So that's what that -300 means. So when you're looking at this timestamp, 9:17, it's -5 hours behind GMT, or UTF, I should say. The reason why I'm saying that is when you look at your transaction log files, and recently you have started shipping a tool that allows you to format your transaction log files, every timestamp in the transaction logs is in UTF. So if you want to match DB2 Diag.log timestamps with the transaction logs, you will need to convert the Diag.log timestamps to UTF. Another tool that's frequently used is DB2 level. Again, not spending too much time. It basically shows you the instance that you're running, the release level, and where it's installed. So the fix pack, mod pack, all of that information, very important. DB2 Support, a very popular tool. It's basically a glorified zip with some enhanced functionality, which allows us to collect data for, let's say, query performance issues and stuff like that. But again, the core of the tool is nothing but look at DB2 configuration, gather as much as you can, look at the OS information, gather as much as you can, collect and compress everything from the DIAK path, from the DB2 dump directory, and produce a file called DB2 Support.zip. So that's pretty much all it does. You will see on this slide there's some my favorite switches or examples. I typically use -C if the database can be connected to. If you don't use -C, DB2 Support will not connect to your database, as a result of which it will miss some of the critical DB configuration information in snapshots. So if your database is connectable, please always do use that -C option. DB2 DIAK, just like DB2 Support, it's a glorified grep. This tool allows you to filter through your DB2 My favorite use is in MPP configurations when I'm running multiple logical partitions, database partitions on the same physical host. I like to filter by node because every node is producing or writing data into the same DB2 So if I only want to see what's happening at node 1, I will use DB2 -node1, and it'll only produce or filter messages from node 1. Another not so frequently known use of DB2 DIAK is it allows you to translate a DB2 return code from its numerical value to the text representation. And if you have seen my presentation, the previous night show that I did with Scott some time ago, you will see a session called My Favorite Problem Determination Tricks that has more detail on this part. A parse, that's how IBM calls bugs. A parse are authorized program analysis reports. Every time there's an APAR, it means that there's a corresponding fix in DB2. There's a code change in DB2 that needs to be fixed. When you're searching for APARs, it's good to include some very specific, hard to, or I would say unique numbers or unique text strings. So it's very similar to Google searches. When you're searching for, I don't know, how to fix my broken window, you will see a million replies. When you see, hey, where do I get tainted glass 5 mil thick, you know, that's a completely different response. So it's the same thing with DB2. Search for SQL code such as, you know, SQL 1042. A good search string is also the function that produces the error, or the probe number, or the function and the probe number, the combination of the two. Those are all good search strings. Which concludes the theoretical part, and we can deep dive into the first section that's dealing with trap problem determination. A trap, what is a trap? We actually have two terms in DB2 or in IBM. A crash or abend is anything. It means that anything went down. It means that there's a system outage. Abend is probably an IBM acronym that stands for abnormal end. A trap is a subset of the first class, of the first term. It's a very specific case when DB2 dies because DB2 has done something illegal in terms of the operating system. So the operating system is shutting us down. Usually it's an invalid memory access or stack overflow or stack corruption, something that is not allowed for the user program to execute on the operating system. So the operating system is shutting us down. So that is a trap. There are other cases of outages in DB2. There are panics, which means that DB2 has come across an unexpected condition. And while everything is fine from the OS perspective, DB2 is not happy. DB2 is not fine internally. So we decide to panic and shut down. So we are killing ourselves. So that's another subset of the term a crash or abend. When you're talking to IBM support, always try to use the right term. When you're talking about a trap, typically means, yeah, DB2 has come down because of something external. Panic shutdown, DB2 has come down because of something internal. When we're talking about the scope of the outage, my favorite approach is start with the instance, see if the instance is alive and kicking. So issue some instance level commands and see if you can get a response. If the instance is up and running, then you might have a database abend. So that means that a specific database that's cataloged under the instance has shut down, has gone down. However, the rest of your databases are fine. There's a clear distinction between an instance abend or a database and a database abend. The trick or the key is if you have to run DB2 start after the outage, it means that this was an instance shutdown. It was an instance event. If you have used DB2 before version 9.1, you might still remember that every process in DB2 was a separate process in the operating system. So DB2 agents had separate process IDs, the engine, DB2CC had a separate process ID, FMP, everything, check password, all of these EDUs were implemented through separate Unix processes, each one of them having a unique process ID. Now that's a history. Since 9.7 and newer, everything, all the agents, all the FMPs, and all of the engine EDUs are shielded in this one single DB2CC process. This DB2CC process is just one process from the operating system's point of view. However, its individual threads are implementing DB2 EDUs. So an agent is a thread, a prefetcher is a thread, a page cleaner is a thread underneath this DB2CC process. If you want to display your threads, you can use, for example, DB2PD-EDUs, which will do a breakdown of the EDU ID and the name, the user time, and the system time spent. Windows has always been multi-processed and multi-threaded, so Windows has DB2CCX.exe, CCS.exe, and underneath there are the individual processes as well. So exactly the same as on Unix. The runtime environment of DB2 consists of the usual stuff. So for those of you who are C developers or developers in general, it will come as no surprise that DB2 comes with executables. So this is the engine executable, DB2 start, DB2 stop, so on and so forth. And then we have application libraries. And these application libraries and executables depend on C or C++ runtime libraries. DB2 is written in C++. So the C++ libraries eventually talk to the operating system. Now we are responsible for the blue part on this screen. If you are debugging DB2, please be aware that most of the functionality is not in the executables, but it's in our libraries. The biggest library in DB2 is libdb2e.a or .so.1, whatever operating system you're using. On Windows, it's db2engn.dll. It's the biggest file in your lib directory, and that's where most of our functionality lies. So when you're debugging stuff, or disassembling, or looking at what exactly these executables are doing, I'm not even sure if you're permitted legally to disassemble our stuff, but if you are, then don't look at the binaries, look at the application libraries. I'm going to skip this slide because it's just too detailed for most of the audience, but the bottom line is that if the DB2 traps, all you need to know is the library name, where it was loaded, which address the library was loaded at, and the failing address. So these three pieces of information will give you an idea. It will always lead you to the source, to the line of code in C++ that had caused the outage. So library name, where it was loaded in the address space, and the relative offset within that library where that exception happened. And that's exactly what I've just said, so I'm going to skip that. Again, I'm going to skip that. Some of the slides are used for our internal education as well, so I'm actually sharing with you the same materials as we used to train our new hires. So the purpose of this slide is just to demonstrate or explain that DB2 has its own signal handlers on Linux or on Unix, which means that if there's a trap, if there's an exception and the operating system decides to kill us, the first chance at processing this exception is given to DB2, DB2 signal handler. So the signal handler will produce all of the trap files, all of the nice data, all of the DIAK log messages that we produce, that we have. Then DB2 will reset the signal handler to the default, to the operating system default, and re-execute the same instruction again. at which point the operating system takes over. And if, for example, for SIGSEGV, the default action is to kill, then DB2 gets killed and a core file gets produced. So there are two intervals at which we will process that exception. The bottom line, the very bottom line again, is that if you want to kill DB2, issue, for example, kill-11 or kill SIGSEGV to the DB2 CPID, you have to do it twice. The first chance is given to the signal handler, then we reset it, you issue the kills for the second time, and that's when DB2 goes down. On Windows, it's exactly the same, so except that we don't use signals, we use exceptions. Here's what's going to happen when a trap file is detected, but I think it's too detailed for this presentation, so I'm just going to move on. We also have something called trap resilience. Most traps that you will come across, that you will find in your real life, are not sustainable because they're happening in the engine. But be aware that DB2 has implemented sustainability, and there are certain criteria that allows us to determine whether or not we can survive that trap or that crash or not. So in this case, here's the list of criteria. Again, these may change between releases without any notice. But for example, if something's running outside of the engine, such as the, I believe it's the vendor process, DB2 vent, and if DB2 vent experiences a signal, we don't kill the entire instance. We typically try to survive. Okay, here's the most important part when it comes to trap files. When it comes to trap problem determination. Trap files contain the key, the crucial information for root cause analysis. It's basically a snapshot of what was happening in DB2 while the problem arrived, while the operating system decided to kill us. It's a text file, and you will see that on the next slides, with some XML tags that allow us to process this file in a machine processing way. The file is named using this specific naming convention, process ID, which is the DB2 sysc process ID, then the EDU ID that received the signal, node number, .trap.txt. On Windows, it's similar, process ID, TID, trap.bin. Obviously, on Windows, the trap file is binary. There's a reason for that. I'm not going to get to that. It's kind of a technological reason that's associated with Windows. But we do have a utility called DB2XPRT that allows you to format that trap.bin and produce trap.txt. On Linux, Unix, it's a text file, so it's perfectly readable in a text editor or viewer. Here's an example. Scott, I think we're half of the hour. Did you want to do your break now?
Can do, if this is a good breaking point for you.
Okay.
Let me flip things around here. Center, show screen, slide deck. Move your mouse. Okay, I've got a polling question to ask. Let's ask our good-looking audience what releases of DB2 they're currently running. There were some questions that came in while you were presenting, Pavel. Someone was wanting to know if they'd be able to get a PDF of the class. Would you be able to share a PDF that we could include in the replay?
Absolutely.
Yes?
I'll be happy to. The very last slide has my contact information as well as my Twitter handle, so I'll be happy to share with anyone who's interested.
Okay, do you want me to put the PDF in the replay blog?
We can do that as well.
All right, then you can send me the PDF after the show ends today.
Mm-hmm.
That's great news. I can see a lot of people in the world are smiling right now. They're going to get the PDF. all the reference materials and the commands that you have. It's great.
I'm smiling too because that means less cases for IBM.
That's right. So 89% today on version 11.1, 48% 10.5, 20% 10.1, 22% 9.7, 9% 9.5 or earlier. Well, that's the best 11.1 numbers I've seen yet. That's fantastic. Okay, that's it for the polling questions for now. Later on during Pavel's class, we will have some questions that he's asked me to ask everyone, kind of related to the class, so stay tuned for those. We'll get those out later. A commercial break from today's show sponsor, DBI Software, smarter tools for smarter people. DBI has made it very easy for you to see a demonstration of their tools. Just go to dbisoftware.com/demo.php. If you watch a demo, they'll send you a $15 Amazon gift card. That's a good little deal. Spend some time and get some shopping money. And Pavel, let's put you back on.
Okay, I'm showing my screen and switching to a full screen mode. And I believe we should be good to go now.
I'm still waiting for things to catch up on my side. There we go. I see it.
Okay, perfect. Excellent. So we have finished at the trap file section. Here's some information that you will see located in DB2 trap files. The stuff that's highlighted in red is what I personally care about when it comes to investigating traps. So I definitely want to see the signal, or on Windows, the exception, which has generated the dump, or the trap file. I want to see the process and threat ID, obviously. And this is just my favorite thing to do. I want to see the registry dumps and disassembly. That's because I'm crazy enough to look at the disassembly, and I love that stuff, to be honest. But in your case, or in most people's cases, you will only want to see the call stack, and we'll get to that part later. So moving on to the next slide. Okay, here's the trap file header. So the header looks kind of similar to a DB2 Diagnostic Log message, so you'll see all the build information, process ID, and stuff like that. Underneath the first piece of information, signal number 11, that's what's really important to me. This tells me what type of an outage this was. Signal 11 means typically invalid memory access. I'm trying to access memory that has not been assigned to me, so most likely there's an invalid pointer in DB2 that is pointing to a dead memory area. Then you will see a stack, call stack section in the same file. What is a call stack? It's a sequence of DB2 function calls or routine calls leading to the place of the outage. So you need to read the stack from the bottom. So in this example, from number 13, which is DB2 main, goes to 12, run instance, init edu services, run GDS, create edu. These functions were called in this sequence until we reach drop table, drop object, SMS delete object, SMS get opening for open container, object file name, and we failed in string copy. So string copy is the most recent function on the stack, and that's the one producing or causing the signal. Now, in this case, I would argue that string copy, being a CLIC function, is solid. It's probably not string copy that's failing, but it's the caller of the function, SQLB object file name, that is somehow passing incorrect arguments to the function. Signals. Here's a reference for you. What signals you will see in DB2 trap files. SIG-IL typically means that there's a stack corruption going on. SIG-FBE, not very common, but I've seen it before. Floating point exception. SIG-trap, usually memory misalignment. Used to be very prevalent on HP units. Same with SIGBUS, actually. SIG-SIGB is probably the most frequent one. That means that there's an invalid pointer going on. SIG-KILL, that's not something that you will see directly in DB2 trap files because that's the most privileged signal that cannot be masked or traced. But you might see a glimpse of SIG-KILL somewhere in DB2 Diag.log, especially when you see a message from DB2 watchdog, hey, I had to kill DB2 and here's the signal, SIG-KILL. On Windows, it's the similar picture. Most frequently, we'll see access violation, C05, and then the rest, floating point exception and divide by 0, stack overflow. It's pretty much the same on Windows. The symptoms of an abend are typically 1224, database manager is not able to accept new requests, or 1032, no start database manager command was issued. Both of these messages are telling you that something has died. Now the first one, 1224, it can also happen if you're doing force application all, so don't be alarmed, don't assume that it's always a trap in DB2 that's producing this message. The second one means that there's no instance running. So the second one is usually very, very critical. Okay, here's a workshop environment, and this is a real-life example. That's why I'm showing you version 9.7, because that was the only way for me to reproduce the problem. This was a problem that was reported from the field as soon as we released 9.7 GA, and it took us one fix back to fix it. So at this point, I would switch to my virtual machine, and I would show you the hands-on demo slash live session showing the trap and showing everything that's happening in DB2. But for now, let's stick to the slides, and maybe we can revisit that at the end. So what I'm doing in my demo is I'm starting DB2, and I'm connecting to database sample. And then I'm doing alter table space managed by automatic storage. And the next command, alter table space lower high watermark. And the next command, list tables, is producing a very unexpected output. It's producing SQL 1224, the database manager is not able to accept new requests. So at this point, my database is probably experiencing some problems because list tables should produce the list of tables that you have in your session. If you were to do a DB2 connect or any other DB2 command at this point, you would always see the same message, SQL 1224. So what do I do in this case? You might remember that on one of the previous slides, I mentioned that the most important thing is narrow down the scope. Narrow down the scope. So where is the problem happening? Is it happening at the instance level? So I'm doing stuff, or I'm running commands such as this DB2 list active databases. And that's a database manager level command, DBM instance level command. And it's telling me, yeah, no start database manager was issued. I'm issuing DB2 NPS, which is a glorified PS command. That's customized for DB2 that will only show DB2 processes. So DB2 NPS node 0. I want to see all DB2 processes from node 0. And I'm getting no output. I'm getting blank screen. I'm just getting the headers, but absolutely no process IDs, no data whatsoever. You can also issue your favorite DB2 PD command. It can be -edus, or it can be just DB2 PD dash. Nothing, with nothing followed by after the dash. And you'll see a message saying, hey, unable to attach to the database manager on partition 0. Now, all of these three pieces of information are telling me that my instance has died. This is an instance level outage. We will need to run DB2 start eventually once we've analyzed what happened. So here's a summary of what data has been produced at this point. So we have some errors in the DIAK log, definitely have messages in the notification log. We will usually have some errors in the operating system log as well. Most importantly, we will have trap and dump files in the diagnostic path. And we will also have core dumps and SWDC packages in the DIAK path. Okay. So we know that we need to go to the DIAK path. Where is the DIAK path? DB2 get DBM config, grep DIAK path. the DAG path is at the default location of the home DB2 install SQ array. I emphasize that this is a very important step if you're working on a system that you're not exactly familiar with, which in my case is 100% of the time. You don't know where the customer or where the user has pointed the diagnostic path directory. Don't assume it's the default. Don't make any assumptions at this point. Always double check that the DAG path is where what the DAG path, the real location is. If you do a listing on that diagnostic directory, you will see the usual diagnostic log, notification log. You will also see a package called FODC trap with a timestamp. Okay. The presence of the FODC trap directory tells us immediately what kind of an outage we're doing. It's a trap. Yes?
Pavel?
Yes, I can hear it.
Myself and some others are starting to get a lot of noise distortion on the audio. I don't know if something's happened on your end Wi-Fi wise or something. Do you have a phone that you could try?
I can definitely try a phone, yes. It might be a better idea. Let me try.
Yeah, so there's on the go to webinar, there's the audio tab, and I think you switch to phone, it'll give you dial-in instructions.
Scott, can you hear me better now?
I can hear you. And
yeah.
keep talking, and we'll see if that distortion issue is cleared up.
1 2 3 1 2 3 1 2 3 1 2 3.
You're very good at counting.
Better?
Yeah, that sounds okay.
Okay, I will switch to a regular phone when there's a bathroom break at the top of the hour, because I need to switch to a better phone system here in the room.
Okay.
So hopefully this works okay for now, but then I'll try to use my regular phone at the end.
Okay, 12 minutes to bathroom break.
Excellent. Okay, so we have the FODC trap directory that tells us that we have experienced a trap. What's in there? Well, the first thing is to look at the DAG log. We need to find the first timestamp that is pertinent, that relates to the outage. So we definitely have a message that says SQL agent 6SegB, error in agent servicing application with coordinator node. I have some favorite strings to search for, such as error in agent, or PD EDUs in DB2 kernel operation, or this one or that one. All of these strings can be used to identify pretty much the beginning of the outage, where it happened in DB2 Diag.log. Okay, but if you're not sure, then the trick is to look at the preceding messages. And first of all, look at the time difference between the presumed start of the outage, which is 11:30:45, and the last message, the most recent message just before that. So that happened about 5 seconds earlier. 5 seconds is a lot of time in a database world. So it's most likely that the previous message is unrelated. But we don't know yet. We don't know for sure. The next indicator to look for is the EDU ID. In the trapping case, we have EDU ID 31, and that's how the trap file is also named. But the previous message was produced by EDU 26. So this also tells you that the previous message is most likely unrelated, and the real beginning of the outage is right here. SQLB extend movement entry point probe 4829. So you will want to investigate this message and anything past that message. You will want to disregard anything that's prior to that. So that's so much for DB2Diag.log. We know from DB2Diag.log some strings to search for. We know the function name. We know the timestamp. The next thing would be to look at the FODC trap directory. And inside, you will see that trap.txt for edu31. Okay, once again, edu31, edu31. So we are looking at the right file. Inside that trap file, you will see the signal number, and you will see the call stack leading to the situation, to the outage. Now, the call stack in the original file would be a little bit hard to read. It would be prefixed and postfixed with some mangling characters that are added by the C linker to the function name. So if you want to demangle those cryptic characters and just translate all of this to DB2 function names, you can use a utility called C++ filter, which is part of your compiler. It's not a DB2 utility, it's a compiler utility, which is typically installed on your machine. And you will get a little bit cleaner output without the mangling information. So again, starting from the bottom, what I see is extend movement entry point, and then reduce containers, and then something that looks like a commit, and something like delete pending. Again, at this point, you will not know. You will be guessing based on the function names, but that's all right. All of these functions are searchable strings. You can search for these functions when you're looking at a parse. The most important information is the trapping information, is the trapping function sqlb alter pool act. Anything that's above, that starts with sql edu code trap handler and above, you can ignore that. That's just the signal handler producing this information. So the signal handler itself also has a stack, and as such, it needs to be included in this file because we want to be complete. But the trap actually began right here. And the trap, if you are familiar, well versed with registers, will also have the this address as the trapping address somewhere in the trap file, just above. So we know that we trapped after alter table space, and it's an instance-wide trap. We have 6 SIGB. We have a stack that's indicating that the failure happened in sqlb alter pool act, and the first dialog message is sqlb extend movement entry point. So perhaps something to do with extend movement. At this point, you have done your job. That's as much as you can get, unless you have access to DB2 source code, and if you do, please don't tell me. Then that's all you can do. So we will search for these strings at our IBM Support Portal, trap, blah, 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 sqlb alter pool act, sqlb extend movement entry point, and we get IC62375 trap and alter table space. That's exactly your hit. You will open up that 8par, click on that link, and you will double check that the symptoms that are described here in this link are matching your DB2Diag.log and your trap file. That's essentially all you need to do. The symptoms that are described inside the 8par might be platform specific. So, for example, if this happens on Windows, there might be slight deviations, but I would say is if 80%, 90% of the description is pretty much matching, and if your DB2 level is vulnerable to this bug, to this 8par, your job is done. That's it. That's the bug that you're experiencing. I have 2 appendixes, and maybe we can do the washroom break a little bit early. So the first appendix is just common prefixes for function for IBM for DB2 function names. So as I told you before, function names begin with a prefix and then something that's human readable. The prefix of SQL or SQU means it's a backup and restore function. SQB means it's a buffer pool services function. SQF is config, so on and so forth. So this can help you isolate the failing component. For example, if you're trapping and load or optimize or whatnot, all of these functions will have these specific prefixes. The second thing that I like to mention is sometimes if your system is configured properly, you will get a huge core file. The tendency of most customers is to delete these core files as soon as they happen because they consume a lot of disk space. I would suggest that you don't do it right away. Please wait for IBM Support to give you the green light to delete the core file. In some cases, the trap information that we produce is insufficient. It's virtually impossible to determine the failure, the real problem, the root cause, in which case we will want to load the core file and basically examine the memory layout for your process for DB2 and try to explain or try to figure out what happened from the core file. Typical cases would include memory corruptions, because the trapping ID is not the one causing the outage, it's a victim, but the root cause is usually a different guy that has overwritten memory for the trapping guy. Okay, so that's essentially what core files are for. Now, there's also a trick that I like to advertise. If this is a reproducible problem and if you want to experiment with DB2 a little bit, then you can enable this DB2 Sleep registry variable. So you can do DB2 set DB2 Sleep equals on and reproduce the trap. And DB2 will fail as expected in this case if you're reproducing a trap. But instead of shutting down, it will sleep before shutting down. It will just put itself to sleep, and you can still run DB2 PD commands, and you can still connect your debugger and attach to that live DB2 process, except that there's nothing happening in DB2. You won't be able to connect or do any database activity, but you will still be able to debug DB2 because the process will still linger around. So that's DB2 Sleep. If you want to resume, wake up the instance and proceed with the crash, and you do DB2 PD CFG-wake up instance. The last appendix is just the reference to debuggers. I'm not sure how many of you use debuggers on a daily basis. Personally, I do a lot. So here's a reference of my favorite commands and how these commands are translated into each debugger flavor. That concludes our first part, traps, and we're on to data corruptions. Scott, I think that we're okay to take a break for now. So over to you.
I think it's excellent timing. We can leave you as the presenter, or we can switch back to me. How long do you think of a bathroom break do we need? 8 minutes? 5 minutes? What do you recommend? How long does it take you to go?
I'll stay here for now. So it's up to you, Scott. Yeah, your call.
All right, let's give people 8 minutes. Down the hall and back they go. 8 minutes. I'm going to set a timer here on my iPhone for 8 minutes. On our marks, get set, go. And when that 8 minutes is up, we'll get to hear the famous duck from DB2's Got Talent. Time's up. Welcome back, Pavel. Welcome back, everybody. I hope you had a good little break and took care of business. We'll have another break at the top of the hour. Pavel, it's your show.
Thank you, Scott. I'll just wait for you to give me control.
You should have control. I haven't taken it away from you.
Oh, okay, so you can still see my screen?
Can still see your screen. Data corruptions.
Perfect. Okay, so let me move on. Data corruptions, that's the next segment in our seminar. So we will start with some basic definitions as well. We do know what a crash/event is, so this term has already been explained on the previous slide. In this part, we will mostly be talking about panics, self-induced crashes. So this is what happens when DB2 needs to, for the lack of a better word, commit a suicide. So something unexpected has happened in DB2 as a result of which DB2 panics, and the database typically goes down, the instance goes down with it. After the panic, after the initial outage, there's usually a secondary outage, such as marking the database bad, or FODC shutdown, or this and that. Typically, you're not interested in these cases. You will only be interested in the initial occurrence, initial outage. When it comes to data corruptions, the most critical tool that you need to be aware of is DB2 DART, Database Analysis and Reporting Tool. It's an offline tool for checking the architectural correctness of a database. Obviously, DB2 DART, because of its offline nature, can detect a lot of problems resulting from mismatches between DB2 metadata and the actual data that's on the disk. So in a sense, DB2 uses some metadata in our table spaces or somewhere or elsewhere on the disk to describe what's in the table spaces. If there's a disconnect between these two, your database is corrupted. That is the essential reason why DB2 DART is offline, and unfortunately, it can never be online. We need to make sure that that whatever is on the disk is not changing while we're looking at it. Otherwise, we won't be able to detect inconsistencies between metadata and the actual data. However, we do have another tool called DB2 Inspect. I'll get to that later, which is fully online. You can run that while your database is up and running. It will be able to detect page corruptions and problems with your data. But its use is slightly different from DB2 DART in the sense that Inspect will not be able to detect all of the metadata problems that DB2 DART is capable of detecting. So they have slightly different roles. Anyways, for now we're talking about DB2 DART. Here are the common options, or I should say my favorite options. If you want to inspect the entire database, you will use the /db switch. An individual table space would be /ts, an individual table would be /t. The default operation, if you don't specify anything, is /db. You can also use DB2 DART to dump formatted table data in an ASCII format, /ddel. You can also dump hex format or hex pages or the raw data using a different switch that's not described on the slide. You can use DB2 DART /mi to mark an index invalid. And there are some examples at the end of the slide about how you can use DB2 DART with your database. The first example is a full database inspection. The second one is I'm only inspecting table space 4. And the third example means that I'm only inspecting table in table space 2, object ID 5. So table 5 in table space 2. So that's how you supply arguments to DB2 DART. If you do DB2 DART /h as in help, it will show you a very detailed, comprehensive screen explaining all of the individual options. Inspect, as I mentioned earlier, is an online, I shouldn't say equivalent, I should probably fix this slide, complement to DB2 DART. It runs in the engine, so it uses prefetching. It runs as fast as it gets. It tries to load or do things in parallel. So it's very fast compared to DB2 DART. It does not have any formatting or repair options, unlike DB2 DART. And it's got slightly different problem detection capability, and I already explained that. So it won't be able to detect some of the metadata problems that DB2 DART can detect. DB2 Inspect creates a binary output file which will reside in your diagnostic dump, in your DB2 dump directory. And you can use the DB2 inspect format tool to format the binary file. At the end of the slide, we have an example: connect to my database, inspect, check table space, result keep inspect.out. So this will be the binary file with the inspection results. And then we do DB2 SPF, inspect format, inspect.out, inspect.fmt. It's very simple. Why are we using a binary file? Because it's fast. Inspect has been designed with the idea of being as fast as possible. So that's why we're using a binary file, and unfortunately, it gives a little bit of a burden on the user in terms of formatting the file, but I haven't seen that as a major concern yet. Another tool that you want to be familiar with is DB2 Check Backup. The primary purpose is to check a backup image and check its integrity, see if there are any bad pages, any mismatches. I would recommend to use that when you suspect corruption in your backup image. You can also check some of the metadata in the backup image, but I need to give you a little bit of a disclaimer. And that's something that we're trying to address, but it's still work in progress. DB2 Check Backup, just like backup itself, is not object aware. It recognizes a page. It knows what a DB2 page looks like and what it should look like, but it has no idea which object should own that page. So it's a physical integrity test, but it's not necessarily a logical integrity test. For example, if there's a page that has a header and that page belongs to a LUW, which don't have headers, then unfortunately DB2 Check Backup will not be able to detect that. And again, that's something we're trying to improve, but be aware of that. So if you basically corrupt a page, already with zeros, DB2 Check Backup may not notice that, because it will assume that since the page doesn't have a valid page header, it belongs to a LUW, therefore it's okay to skip it. So be aware of the limitations of the tool. Again, at the end of the slide, there is an example on running DB2 Check Backup. For a TSM backup image, we have the DB2 LUW tool used with the verify option, which is exactly the same as DB2 Check Backup. When we're talking about corruption, and I've already touched on that, we can have either physical corruption, which means that the data is physically damaged. So, for example, a database page contains nothing but zeros. These types of corruptions can be easily detected by DB2 Dart, Inspect, or even if you look at the table space visually and you see a bunch of full pages and all of a sudden a bunch of zeros in the middle of full pages. So that could be a good visual indication that something's wrong with your table space. The root cause can be different or can vary for these types of problems. It ranges from anywhere between an operating system failure or a bad drive controller to a DB2 bug. Now, typically these types of problems are not C-bit errors, and I'm not sure if I have a slide on C-bits. If I don't, I need to explain what C-bits are for. C-bits are consistency bits that are used in the middle of a DB2 page to detect whether the page has been written in full. In full. I need to repeat that. So C-bits are meant to detect partial page writes. So basically what we do is at specified intervals on the page, we will flit a bit here and there and just store the original value somewhere in the page header. And if when we're reading the page, if the bit values don't match our expectations, it's clear that the page has not been written in full. Maybe only a half of the page got written out to the disk, but definitely not the entire thing. So that's what C-bits are for. Don't confuse it with checksums that we use in newer releases since 10.1. Logical corruption means that the page is physically okay. However, for example, its owner, it has no owner. Nobody claims that page. Or the owner thinks that this should be a LUW page, but it shows as a data page. Or the owner thinks that this should be an index, but it's a data page. So that's logical. So physically the page is okay, but it's a page that doesn't make sense in the context of runtime. The root cause in this case is usually a DB2 bug. If there's a misplaced page in the table space. However, I have seen cases where, and that's on the funny note, where pages in the table space were just randomly copied from random files from random file systems, and that was an operating system error. So we got some Harry Potter books pasted in the middle of our table space, And those were just text excerpts from Harry Potter books, and it was so funny to watch, to be honest. That's one of the cases that's definitely not a DB2 error. I mean, we don't store our data as a Harry Potter book. What can happen, or what you might see, is a page that belongs to a different object is pasted in the wrong table space or in the wrong part of the table space. So those, it's questionable. Could be DB2 problems, may not. Hard to say. There is a thing called error toleration. So we try to, if there's a problem reading a page, we will first of all retry. We will try to read the same page again, and if the second attempt works, then we will proceed with that page, but we'll produce a huge warning in the DIAK log. But if we cannot read the page from the disk, we will still try to tolerate that error and see if we can survive the outage, maybe terminate the offending transaction, but keep the rest of the system alive. This behavior can be controlled by the DB2 resilience registry variable, which has been on for the last 3-4 releases by default. Okay, I'm going to skip this slide. That's just the sequence of operations that happens during a physical page error. Again, logical error toleration is the same thing. This slide explains what we do when we find inconsistencies, logical inconsistencies with the page, but the bottom line is the same. We will try to get the page out of the buffer pool if we can, and reload it again, and again produce a huge warning in the DB2 Diagnostic Log. And that's the flow of operations and the admin error that's going to get logged for a logical bad in-memory page problem. The next thing before we get into the demo is signals that distinguish aborts from traps. Most frequently, your trap file will contain SIG-abort number 6, signal number 6, which means this is an instance panic. On Windows, you will see exception E, a bunch of zeros too, which also indicates that this is a panic, it's a self-induced crash. Here comes the exercise. So again, this would be the live demo. We are connecting to database sample, creating table, C1, T1, blah, 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 importing from a file, creating an index, insert, and this is an uncommitted insert, and then we're doing a rollback and terminate, DB2 stop, DB2 start. We try to connect to sample again and delete from that table, and all of a sudden we're getting SQL 1034. See, the database is damaged. Now I should explain or emphasize that this is yet another real-life example. This is an APAR that was reported from the field again some time ago during 9.7. But this is exactly what you would see when you're dealing with data corruption. The initial part of your investigation should be pretty much the same as with traps. So you will want to narrow down the scope. I've said that a few times already, but I'm going to say it again. Please narrow down the scope. See if it's an operating system issue or scope only, or if it's affecting your DB2 instance. Typically, this is definitely a DB2 problem, so you would start with the instance, or if it's affecting only one database. So in this case, you're doing this list active databases, NPS, DB2 PD. All of these 3 commands are producing the same output as in the previous exercise, meaning that the database manager is down. We will need to run DB2 start. So the entire instance has been shut down, and we definitely need to hurry up and make sure that we start as soon as we can while we have at least some understanding of what happened. The next step is, again, very similar to the previous step. So we get the DIAK path, and we do a listing of that DIAK path, and we'll see a bunch of files, DB2 Diagnostic Log, but we will also see FODC panic, FODC index error, FODC DB marked bad. So there are 3 different FODC directories here. Which one am I looking at? Well, it's easy to answer. Look at the timestamp. You will want to have a look at the earliest one, at the oldest occurrence. So marked bad is 12:51:22. Panic is 12:51:23. Index error is 12:51:21. 21 is the earliest one. So you will want to start with FODC index error. Before you go there, have a look at DB2Diag.log, just like in the previous case. See if you can find the beginning of the problem. In this case, you will definitely see the timestamp of the FODC directory creation. So from there, you can scroll back in history until you find this jump between timestamps from 5104 to 5120. And again, jump from EDU17 to EDU26. So typically, in most cases, this would be the start of your problem. 12:51:20, SQLi cleanup empty leaf probe 1213. That's where most likely the problem started to happen. Next, we can look at the FODC index error directory and locate the trap file for EDU17. So we already know that it starts with the engine ID, process ID, 17, which is the EDU ID, node number, stack.txt. Note that the name has changed slightly from trap.txt to stack.txt. That's okay. That's normal. Trap.txt is only reserved for traps. We also have a new directory called Dart0000, and that's as much as we know for now. Let's have a look at the trap file. So the first thing is after the header, you will see signal 12. I did mention that in most cases you will see signal 6, if you remember. However, in this case, we have signal 12. How is that possible? Well, the signal 6 is used in the suicide. So it would be here in the panic directory. There would be another trap.txt or stack.txt with signal number 6. It would also most likely be, I'm not 100% sure to be honest at this moment, it might be present in the DB marked bad directory as well, but it'll definitely be in the panic directory. So that's the suicidal signal. But before that, we also use user-defined signals, any signal that's free on that particular platform. In this case, we're on Linux, and signal number 12 is not really used for anything meaningful. So we use that signal 12 for producing our trap information. Okay, so don't be alarmed. So signal number 12, which is okay. And as I said earlier, you start with the bottom. There's some row delete, key delete, delete key, and dump context, dump edu, pthread kill. Once you come across that sklo dump DIAK info handler, anything above that you can just ignore. That's the signal handler. So the problem happened here in pthread kill, but I would argue that it's not the pthread kill that's probably the problem, but it's whatever was preceding to that pthread kill. Pthread kill means that we're terminating the current thread. So just going back, dump edu, we're probably dumping information for the current edu. Dump context, we're probably dumping information for the current edu. And this skli stands for index manager. Delete key, del key. That's most likely the problem. Okay, so there's a little bit of a twist here when reading the stack file or trap file. Okay, so just to summarize, we have trapped when deleting data from T1, which might possibly be reproducible. The instance went down. Signal 12, user-defined signal, means that we have generated our data, and followed by the abort, signal number 6. The most recent routine on the stack is del key, and the first message in the dialog is skli, again, index manager, cleanup empty leaf, and the name is DB2 agent. Again, at this point, you can search for a parse, and boom, we got our APAR. So there are 2 hits IC 77187 and 77761. I bet that one of them is for one release, the other one is for another release. We need to create, as we call them, sysroute APARs. So each release will have a unique APAR number, so we can keep track of our fixes correctly. So don't be alarmed, but it's the same bug that happens in multiple releases. And if you were to click on this link and examine the symptoms, again, you would be able to confirm that the symptoms or the description are pretty close to what you're experiencing. Therefore, this is most likely a problem. However, your investigation does not end here yet, not yet. We know the error is reproducible, and any attempt to access that table will shut down your instance. That's not good. Definitely not good. I did mention that sometimes DB2 Dart can be used to repair some objects or mark some objects invalid, especially when it comes to indexes. Indexes can be recreated at any time, as long as you have your table, your base data accessible, and everything is in order, everything is fine with the base table. So in this case, we will have a look at the stack, at the DB2 Diag.log again. We know that the problem happened at 12:51, and the table space ID was 3, object ID was 5, and the object type was index. So we happened to be accessing an index when we trap. And here's the parent. Okay. And another confirmation of the same suspicion is in the subsequent message, which says, hey, we're accessing table space 3, pool 3, object 5, type 1. Now, those of you who are advanced in DB2, you know that type 1 is INX. It's an index. Base data would be type 0. So we are failing while accessing an index page. That's a freebie. That's a cookie for us. Because what we can do is we can run DB2 Dart sample just to check if there's any other problems in your database, because it may not be just object ID 5. It might also be object 6 and 7 and 8 and 9. So first of all, you want to map the damage. You want to see the extent of the damage. But in the DB2 Dart output file, you will see that index 5 in pool 3 is the only corrupted object. The rest of my database is absolutely clean. So what we can do is fix it. Just do it. DB2 Dart sample / mark index bad, object ID 5, table space ID 3. And it will come up with that message, modification for page written out to disk successfully. Then you will do DB2 start, connect to sample, select constar from T1, and hey, all of a sudden, nothing's failing. And DB2 says, if you look at the DB2 Diag.log, that an index or indexes on table T1 have been rebuilt. So this extra step, if it's doable, will allow you to repair your database, fix your data, and as long as you're not doing that long step or series of steps that I demonstrated at the beginning of the scenario, you know, all those inserts, uncommitted inserts and deletes and stuff, and the rollback leading to the problem, as long as you try to avoid these steps, then your database will be up and running until you apply the fix pack containing the fix for the bug. Which brings us to the last section of the presentation. It's going to take us another good hour and a half at least. So, Scott, we're at the bottom of the hour. Did you want to do another commercial break, or should I proceed?
Just the one commercial today. We already got it done, so carry on, and we'll take a restroom break at the top of the hour.
Perfect. At this point, I would ask if there are any questions. I'm not watching the chat. Scott, have you been able to spot any questions so far?
There's been some chatter about audio quality and things, but this is the first actual question that's come in for you. To repair an index page, can I drop, recreate it, or would he be prevented from dropping it? I think you can drop a broken index and recreate it.
Okay, that's actually a great question. Not always. Not always. I mean, technically speaking, you can do drop index, but even indexes have some metadata pages that describe the index, where it's located, how many pages there are in the index, what the key or leaf pages are, and so on and so forth. So we call that index page 0. So if that index page 0, the metadata page for that index is corrupted, then DB2 will not allow you to drop the index. DB2 will just say, hey, you know what, the object is damaged. I don't know where the object resides. I don't know what to do about it. So basically, runtime will complain that it's unable to load the index and drop it as usual. Runtime is usually not very permissive when it comes to data corruptions. Every time there is a data corruption problem, runtime will prevent you from doing anything further, any additional action with that damaged object. So it is possible that drop object will actually fail, in which case you will have to use DB2 Dart/MI, because it's an offline tool and it's not runtime.
Very good.
Okay, is that the only question?
That was the only one at the moment. Yes, sir.
Okay, perfect. Let me move on to the next part, hang and performance problems. That's a big one. So we'll start with some theory, as usual. So what is a hang? It's a situation where the database stops responding to incoming requests, or it just freezes while processing existing requests. Now, a hang typically happens when there is a contention on a shared resource. It can be a log, it can be a latch, we'll get to that, but there's some kind of a contention. So that's what constitutes a hang, a contention. Two or more people competing about the same resources. The hang can be temporary, a small glitch, that happens, once in the blue moon. Those are very, very hard to investigate, to be honest with you. And sometimes you can perceive them as a performance problem, or it can be a permanent, when multiple execution threads competing about the resources basically come to a standoff or a reverse standoff. In this case, those who know me, I like to include Canadian references. So you know what a standoff is, a Mexican standoff, when two people are aiming at each other, pointing their guns at each other, and they're in a deadlock. They're just waiting for the next guy to pull the trigger. Here's an example of a Canadian standoff. Just give you a little bit of time to. Okay, but that's essentially the point. Two guys are waiting for each other and they're not moving. So, by the way, this Canadian standoff doesn't apply in hockey. I just want to point that out to you. I know that from my personal experience 2 days ago when we played a game. All right, moving on. The performance problem is similar to a hang, but in terms of its investigation, I actually use the same initial steps to investigate performance problems, the same as I use with hangs. The main difference between a hang and a performance problem is that with performance issues, things will eventually get done. Whatever you're running, it will get done. Probably it'll take longer than usual, but you will not be waiting forever. So that's how I like to classify these two outages or two issues. Now, I did touch on latching and dead latching. So what exactly is a latch? A latch is a very small and fast entity. It's the most fundamental, the most elementary object in DB2 that we use in order to control concurrency, critical sections, synchronizations between or among individual threads. Technically, a latch is usually implemented through a semaphore or some kind of an IPC resource for those of you who are developers. But you can think of it as a very elementary, very small, and a very fast unit bit somewhere in memory that basically tells us whether the next guy should wait or go. So that's a latch. You can think of it as a log. It's got the same purpose. However, a log is a high-level, very user-friendly structure that shows you all kinds of information. You know, it shows you the type of a resource we're trying to access, the people involved in obtaining the log, the duration, stuff like that. So I would say that a log is the next level of latch. It's more advanced, more glorified version of the latch. But latch is something very fundamental, something very small in DB2. In DB2 purescale, we also have a term called lotch, L-O-T-C-H, which is abbreviation from lock or latch. So it makes it pretty hard to understand each other in purescale. Just maybe to summarize, a lodge means that it's a synchronization object that can be used across members. That's why there's a local portion, a latch, which is used to synchronize threads on the current member. But there's also the lock portion, which is used to synchronize other members with me. So that's why it's called log or latch or lodge. A dead latch, as I explained, is, you know, two people or multiple people are asking for the same resource, and they're holding what the other guy wants. The diagnostic data for hangs or performance problems must be gathered while the problem is happening. That's the current situation in DB2. We are working on improving this part. We are working on some mechanisms, or we have been working, and hopefully we will resume that work soon enough, on historical monitoring that will help us with root cause analysis for past performance problems or past hangs. But as of now, data should be collected while the problem is happening. That's especially true for hangs. If your system is hung, don't just kill DB2 and restart it. You know, make sure that you collect at least some basic data. When there's a DB2 problem, a hang performance problem, you might see that it's happening in DB2, but you also need to narrow down the outage to, you know, is that an application, or are we dealing with a network problem? Is this an operating system? So make sure that your base operating system is working fine, and the system and the hardware is not experiencing any issues. That's the #1 step that you want to do in every hang/performance problem determination. My favorite approach when addressing hangs is a top-down approach. So I'll start with the most general ways, the most generic commands, and I try to drill down to the individual layer or individual component or individual function, if I can get that far, that's causing the problem. So I usually start at the operating system level first. Look for excessive I/O, network traffic, errors in the system logs. Then I look at the database instance, just like in the trap and data corruption session, as we saw it. And I try to see if the instance level commands are working well. Then I look at the database scope, and I just run a few database level commands and see what the performance is, whether I can connect. And once I have passed that level, I drill it down to the individual EDU or application scope. You know, try to see if there's only one application that's experiencing the outage or the problem, or if multiple page cleaners, for example, or prefetchers are experiencing the issue. If it's an application issue, is there one agent associated with the application, or is there multiple? Stuff like that. So that's my favorite approach. I call it a top-down approach. Here's an example of what I look for. So at the operating system scope, the highest scope, all, my favorite is VMstat. I usually do multiple snapshots. So in this case, I think it's 10 snapshots, 10 seconds apart. I never get the order right, but I think that's what it means. Usually the first line of VMstat can be ignored. It's some cumulative statistics since the beginning of the system or since the start of the session. I don't remember exactly. But any subsequent lines are reflective of what's currently happening in the system. So VMstat is my all-time favorite. What do I look for in VMstat? Well, I look at the R column, which is the run queue, and that tells me how many threads or how many processes are currently competing above the CPU. My next step is look at the blocked queue, which is how many processes are waiting for uninterruptible operations. There's a little bit of a catch here. I mean, the documentation says uninterruptible operations. What it actually means is that how many processes are waiting for the kernel to respond. And what it usually means is how many processes are blocked on waiting for I/O. Because most of the time when you're waiting for the kernel and you're running a database, 99% of the time you're waiting for I/O. So this D number, if it's too high, can give you a clue that maybe there's something happening with the I/O subsystem. My next favorite part is the CPU statistics. So user time, system time, idle time, and wait time, I/O wait. So user system idle, I guess everybody knows that. That's the usual trio of CPU statistics. User means I'm executing in the user space, system in the system, idle means that I'm doing nothing. WA as in wait is I/O wait. So I'm waiting for I/O to complete. So this wait and B, if they're both high, that means that I'm definitely swamping the system with heavy I/O. So I'm I/O bound. Okay, for instance scope, I use getDB and CFG, list active databases, list application, show detail, and EDUs. Those are just some of my favorites. You can use something else. It doesn't really matter, but make sure that you examine the instance and check that the instance is responsive. Question: why am I not recommending the new monget table functions? Why am I using get snapshot for applications and commands like basically the get interface that should be deprecated. The reason is that the get interfaces don't need a database connection, so they're currently implemented as something that's almost outside of the engine. Whereas monget, it definitely needs a connection. So when you try to run a monget command, you need to be able to connect to your database. If your database is hanging, obviously you may not be able to connect. So that's the only exception that I would make. Otherwise, I would definitely suggest that you stick to monget every opportunity you have, because that's the current trend. That's the maintained version of any snapshots that are in the database. All right, here's the database scope. Again, some of my favorites. If I can connect to the database, then monget database details is a good one, or get snapshot if you like, but in this case, you should do monget. Okay, and just do a few queries from the command line. For the application EDU, you can again do get snapshot for applications, or monget applications, or monget agents. In this case, my suggestion is to do at least 2 iterations, to collect 2 or more iterations of this data, maybe 1 minute apart. Check for movement between these 2 snapshots. Put them side by side in your usual favorite diff command or diff tool. Put them side by side and see if there's any movement, any drastic changes between these 2 snapshots. Now, once we have established that this is not an OS hang or a network outage and so on and so forth, it's time to collect DB2 internal information. Now, this part is probably not very well known, and you may not be familiar with it, so I'll go a little bit slower. So the first piece of information that you will want to that you will want for your problem determination is call stacks. Now, call stacks are, we have already touched on them in our trap presentation and in the data corruption presentation. Those are the trap.txt or stack.txt files that contain the current snapshot of a DB2 EDU. What am I trying to say here? Call stacks can also be generated manually by you being the user. So if your system is hanging or if your system is performing slowly, you can issue a command, and I'll show you this command on the next slides. And that command will go through all of the DB2 EDUs, and it will produce a call stack file for each such EDU. Okay, so that's call stacks. Then you can collect data for active EDUs. In this case, what I meant is snapshots, obviously. So see what's happening in the database. You know, you can use DB2 PD, monget, get snapshot, whatever your favorites are. But you know, take a few snapshots separated by a time interval and do a diff. Watch for differences. Traces. I will also explain them on the next slide. We have a tool that allows us to trace DB2. It's called DB2 Trace. And we can also use DB2 Trace to get profiling information for DB2. Then we can get log information and access plans. These two are outside of the scope for this presentation, but what I'm suggesting is basically, you know, perform log problem determination to see if there's any log contention happening on the system. Usually the easiest way is just DB2 PD-logs. And you should also, if you suspect that the problem is happening with one specific application that's running a specific SQL statement, then you should get the access plan for the application. Okay, let's get to the call stacks. So we already know that it's a snapshot for an EDU, and I already told you that that you can generate this call stack manually. Okay, here are the signals that you will see when call stacks are generated manually. You might remember from the previous example that signal number 12 was also used by DB2 for data corruption. Please be aware that the same signal will also be used if you decide to generate call stacks manually. Okay, so here are the examples of the signals of all the various signals that you will see in your trap files when you generate them manually. Here's the naming convention, stack.txt and stack.bin. The concept is the same as with traps, so I'm going to move on. The contents, again, this slide is similar to one of the previous slides. However, I have highlighted the information that I think is essential for hang/performance problem determination. So what I think is the most critical thing, for example, now I'm not really looking at registry dumps, but I'm looking at the call stack itself. So that's definitely very critical. And then I'm also looking for latch information for the EDU and locks being waited on. All of this stuff is in the stack.txt file for each EDU. Okay, so latch information and locks being waited on. Here's an example of the stuff that matters. So the first part is the call stack, as I mentioned. So we have a page cleaner doing some asynchronous write setup, and it's trying to find and lodge and extend, and it's calling get_sd, val upgrade log, make new request sd. Now this part, the top part, doesn't really matter. What the page cleaner is trying to do is trying to get a lodge, obtain a lodge, acquire a lodge. However, you may not understand that. You don't have access to the source code, so that's fine. But just be aware, you know, take a note of the call stack. Note how many beautiful searchable words, keywords there are in the call stack. So that's the call stack part. Now, in the same file, if you scroll down to the bottom, you will see latch information. And in this case, we have a line that says holding latch type, blah, 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 read latch, address, blah, 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 blah. And here's the line and file in our source code that is trying to acquire this latch, that has acquired the latch. So this tells me that the EDU, whatever EDU it is that we're looking at, owns the read latch at address F8C0. Please be aware that in order to identify a latch, you need to have a pair. So the primary key, if I can use it that way, is the latch name, which is here, read latch, and the address. This pair is a unique key. It's unique for every latch. Some latches may have the same name, but they're at different addresses. For example, tablespace latches. Each tablespace will have a different latch. It'll be named the same, but it'll reside at a different address. So if you see that the address is different over here, it's not the same latch. It's a different latch. Now the next part is that this guy make new request SV is waiting on a log name, blah, blah, blah. It says SQLT val log, EM name. It's some named log for extend movement. It's actually, this example is taken from PureScale. Just last November, I believe, we released extend reclaim in PureScale. And this is what I just took from one of our test cases where I'm simulating a hang in PureScale extend movement, and I'm trying to make sure that the behavior of the reclaim is correct. It tries to back off and basically make sure that things are okay. So here's an example of a real life situation that you might see in PureScale during extend movement. Okay, we already did have the slide or mention this slide, so I'm going to skip it. Here's the big one. How do I generate DB2 call stacks? How do I make DB2 produce all of that information? So on all platforms, you have DB2 PD-stack all. That's our preferred way if you have a single partition. If you're running DPF, multiple logical partitions on the same physical, then you will run raw DB2 PD all DBP-stack all. Raw will send the DB2 PD command to all physical machines, and all DBP will make the command happen on all partitions. If, for whatever reasons, DB2 PD is hanging as well, it doesn't usually happen, but if it does, then you can still revert to the old ways before DB2 PD. So you can still send signal 36 and signal 23 to the DB2 SysC PID if you want. So on IAGs, we would do kill-PRE and the process ID of SysC. On Linux, you would do kill-urge and the process ID of SysC. You will get the call stacks exactly in the same way as in DB2 PD. The difference is that this is an external command that has nothing to do with DB2. This is an DB2 PD as an internal DB2 command, which is preferred. On Windows, if things are not working properly, you have the backdoor debugger. Not too many people are aware of this command, but it's a little bit horrible syntax, but it also allows you to produce call stacks for your instance if DB2 PD is not working correctly. Okay. Other than that, you always have native ways of producing thread information for any process, including DB2. So I typically use debuggers. So GDB and DBX both have commands to produce thread information. So you will connect to DB2 and issue the thread call stack command, and it will produce call stacks for every thread that's in DB2. Operating system commands such as on Linux, you can do cat, prog, then PID, which would be the DB2 syspid /stack, or its tasks, or its threads. So that's how you display the threads underneath your DB2 SysC. Prog stack on AIX, pstack on Solaris, 80+ on Windows, or prog stack on Windows. Those are all valid techniques to produce call stacks if DB2 PD is not working properly. Okay. Now we have maybe two, three slides to go through before we take a break. So I have mentioned that the point is to produce a stack.txt file for every EDU running on your system. What if you have 2,000 EDUs or 5,000 or 10,000? You will get 10,000 files. How do I process all of these files? Do I have to look at every single file and see what's in there? You know, the stack and latch information and whatnot? The answer is no, you don't. We ship a tool called Analyze Stack, which is located in sqlib/pd. All you can do is type sqlpd analyze stack-i followed by the directory containing your stack files, and it'll load all of these files and produce a file called stackanalysis.out. What's inside? Inside that file, we will print the stack once, and below, we will print every EDU and the timestamp which has this call stacks in its file, right? So in this case, we have this cleaner find work, which is the idle loop of page cleaner, and we know that EDU 100 and EDU 75 are both waiting in the same loop, so they're basically doing nothing. So this allows you to process things much faster. Also, one of my recent, I shouldn't say recent, but one of the points is that if 99% of your processes are stuck in something like this, like clean finder work, usually they can be ignored. But if you see one guy that's significantly different from the rest, very often this is the suspect. You know, very often that guy that's doing something slightly different is the guy that you should really have a look at. So look for unique EDUs in your stack analysis.out. You can also run analyze stack with a -l option at the end, okay, which will produce yet another file called latchanalysis.out. This is a sorted overview of latch holders and waiters. Basically, it will produce or parse all of the latch information in all of the stack files, and we'll try to print a graph of who's holding what and who's waiting on what. Now, for you, the most important information is one of the first lines in the output. If you see a line that looks like this, latch wait detected, it means that there is a dead latch somewhere, or latch wait somewhere in your stacks. Many times, latch analysis will say, hey, you know what? There's no waiters, but I'm going to print the holder info regardless. So holders are fine if there's no waiters. So if you see output that says, hey, you know what? I don't see any latch waits, but I'm going to print the output regardless, that means that there's no latch wait on your system. But if you see something like this, latch wait detected, definitely it's a red flag. Okay. I think it's time for a break, and I think Scott, maybe correct me if I'm wrong, but I think I included my first poll question somewhere around this slide.
Okay, you can let me know after the break, and we can ask you those questions that you sent. I'm setting the timer again for another 8 minutes. Dear audience, on your mark, get set, run to the bathroom now. Recording is in progress, and somebody asked a question. They want to know, does setting Oracle compatibility mode, DB2 compatibility vector equals Aura, have any measurable performance impact?
That's a tough question, because as with everything, the answer depends. But I think that whoever asked the question might be interested in the log compatibility. LOCK, lock compatibility with Oracle. So if you do use the Oracle compatibility settings, then our log behavior will be slightly different. It'll be slightly more permissive. So if you're fighting with a huge lock contention, lock escalations happening on your system, you might get a little bit of a relief there. Other than that, I suggest that the person ping me directly through email, and maybe we can talk about a specific scenario, because again, I don't want to mislead anyone into thinking that setting a registry variable, whatever it is, will make DB2 go faster. That's certainly not the case.
Okay. Let's see. Master on the show. Feedback. Can IBM come up with something that is equivalent to OVM on VirtualBox by Oracle? I am sure a lot of us don't prefer to look at Oracle products while learning DB2.
All right. So somebody was watching my screen, I guess. So what I'm using is VirtualBox. VirtualBox used to be an open source utility that unfortunately Oracle has acquired. And it's a replacement or a competitor to VMware, except that it's free. So I'm not sure if IBM is creating something similar. We in the database business, we are creating new features in DB2, so I can't confirm or deny that idea, but not that I know, not to my knowledge. Yeah. For virtual machines, I guess the standards are either VMware or VirtualBox, and the fact that VirtualBox comes with an Oracle logo is unfortunate, but that's the reality, unfortunately.
That's the price of free. You have to look at logos.
That's right. Yeah, I think the same thing happened to MySQL.
All right, I think that pretty well. Here's a new one. How can I catch a query if I cannot use the event monitors?
Okay, if the query is hanging, it's fairly simple because you can use DB2 PD or MonGet snapshots to basically display the dynamic and static cache for the database. If you know which agent is using that query, which is also easy by using DB2 PD-applications-agents- dynamic -transactions, so four of my favorite switches, then you can see the contents, the cache contents of the query. Also, if you produce DB2 call stacks, you will not only see stack.txt files, but you also see dump.txt file, dump.bin files. They are binary files, but they also contain the contents of the cache for the given EDU. So many times, if you just format the bin file using, for example, the strings utility, which will convert or print printable strings from a binary file, you will see the command that the EDU is running. Now, if it's a performance problem, it becomes a lot more complicated. The main answer, usually my main answer is to monitor your applications on a regular basis, and those commands that are running longer should eventually be captured in your MonGet snapshots. Another approach might be to turn on DB2 trace for that specific application only. And in DB2 trace, you will definitely be able to identify any command that the application has ever run. So that would be the most hacker type of an approach.
All right. Did you have a question you wanted me to ask the audience, the polling question?
Yes, please. Yes. Yeah, let's go with the first poll question, please.
Okay. This is where we check with the students in the class and make sure people are paying attention. What is the most critical piece of information when investigating hangs? I think answer A is pretty funny.
Scott, I don't know if I can see your screen though.
Poll
Do I need to stop sharing?
Yeah, poll is open and people are responding.
Okay. Okay, good, good.
We'll give people a minute. It'd be great to get 80% to participate.
Mm-hmm.
Did you get coffee on that bathroom break?
I got some water. Yeah, unfortunately, I don't drink too much coffee, so maybe once every 2 months or 3 months. So
Wow.
I'm not really a coffee person. Yeah. I would love to enjoy that, but yeah, I'm just not.
I think I probably consume your year's worth of coffee in about a day. All right, this is what people said. 19% DB2 trace, choice B. 51% call stacks. And 28% history of actions preceding the error. So
how many people chose the rest? Sorry, go ahead.
Nobody chose the telephone number for IBM.
Okay.
So what's the right answer?
My intention for the right answer was D. Call stacks with latch holder and waiter information. Has anyone selected that?
51% selected that.
Okay, good.
History of actions preceding was the second most popular at 28%. So if you're intending your call stacks, then people were paying attention.
Okay, excellent. Thank you so much, Scott.
Sure. Let me know when you're ready for Q2.
Okay, that should be at the end of slide 125. Okay, so I'm going to move on with the presentation. We're at slide number 100. I still have about 50 plus to go through. So data for active EDUs. What is it that we need to collect? Here's my personal list. Yours might be different. Note that my list includes DB2 PD-latches and DB2 PD-logs and DB2 PD-W logs. The reason is well described in my previous favorite tricks problem determination session. But just to give you a scoop of it, latches, logs, and logs being waited on is a quick way of determining if there's any dead latch. So similar to that analyze stack tool, it will give you a quick idea whether or not there's a dead latch going on. Okay, and the rest is just, as I mentioned, applications, transactions, dynamic, things that are pertinent to your applications. I should have included DB2 PD-agents. DB2 trace, a big one. DB2 trace is a utility which gives us information on what calls, routine calls, were made in DB2, and the actual code path that was taken, and the sequence, the time sequence in which these operations took place. One thing that I should also mention is that if you use DB2 trace with that -T as in table option, your trace will include timestamps. So it's crucial, I should say almost essential, to have this information when you're investigating performance problems. So DB2 trace with -T will show you, or will produce timestamps. Here's a reference slide. Again, we don't need to go through it too carefully. What really matters here is that the first section shows you how you would usually invoke DB2 trace. So DB2 trace on, so that's how to turn it on. And then you dump it and format and flow. So there are two ways to format the output file. You can also trace the DAS server if you have a problem with that. Again, that's a slightly different syntax. These are, the last paragraph is fairly new. There have been some new options of DB2 trace. added recently. One of them, -app handle, allows you to trace your application based on the application handle. And it will also trace all the forked threads or EDUs that the application may spawn. So not just one app, one EDU, but everything, all the EDUs that belong to your application. Or you can use the same or similar functionality with the app ID. Okay, so there's a way to trace a certain app ID, and that pretty much summarizes this slide. Trace is usually dumped into a binary file for performance reasons. The binary file can be formatted in two ways, flow and FMT. Now, this is the flow version. A flow version, as the name suggests, shows you the flow of functions per EDU, grouped by EDUs. So in this case, we have a function process escort request entry point, which calls parallel recovery. So there's a little bit of indentation at the beginning. So this pipe character means that parallel recovery is being called by process escort request. And then you just follow the pipes until the exit point of parallel recovery. And then you just follow the previous pipes to the exit point of escort request. So this is what a FLW looks like. FMT is not sorted by EDUs. It's sorted by time. So there's the sequences in an FMT version of the file, of the dump, are perfectly sorted by time. They're not sorted by EDUs. And they also tend to be much bigger. FMTs usually contain data that's produced by your functions. So in this case, we're looking at the same entry for parallel recovery, but we see that there's some return code here, and there's some dump EMP map info not found. You could also see a huge hex dump in this section. You could see a lot more information than in the FLW file. So the FLW is used, I typically use it as a reference of the flow, who's calling what and at which point. And when I want to see the actual data being produced at the individual trace points, I open up the FMT and I look at it as a more detailed information of what's happening in the FLW. So that's pretty much it. The rest of it you can read in your spare time. There's a lot more information on the slides, but all you need to know is really just these two key pieces of information. Trace can also be used to print a call stack leading to a specific point. Now, I did tell you about the indentation, and there could be a huge wave of not just like a Christmas tree, but you can have people going all the way to the right and then coming back to the left, and all the way to the right and coming back to the left. So there's a wave of calls and exits and calls and exits and calls and exits until you reach the place of your interest. So you redo fast truncate table. And if you want to backtrace who or how you got into that place, with all the noise in between, it might be very difficult. So DB2 Trace also has the capability of printing the call stack leading to a specific trace ID. So the first thing here is the trace ID. If you use DB2 Trace print -stack trace ID, this number, and then the flow file, it'll print just the immediate chain of events leading to that place. No waves in between, no noise, no anything in between. So it's very useful, and it's pretty much the same information as the call stack in your stack.txt file. DB2 Trace can also be used to profile your instance. This is a per instance feature, so the profile will include all of your databases, all of your applications, all across that single instance. DB2 Trace on-perf_count-t, you run your scenario, and then dump the output, dump the buffer, and format the output. You will basically see a table that shows you the number of executions in the first column, the number of seconds that the line is pertinent to, that the line took, and the last piece of information is the actual function in DB2 that took this long. So the way I'm reading it, I'm actually going to start from the bottom. I have about 262 row insert RISR calls that are taking about 9 seconds, 8.9 seconds. Then I have about 500,000 of row insert calls that are taking about 10 seconds. And again, 500,000 inserts that are taking about 11 seconds. All these numbers are cumulative. So if row insert calls row insert, then obviously this is not in addition to 11. This is the 10 portion of that 11. So it's relative to the caller. So again, I have, this was actually taken when I was doing insert into a table, and I had about 500,000 rows to insert. But here's my performance trace, and here's the flow or the data that you will get. Now, the reason why I'm mentioning that is that if something ill is happening on your database, you might be able to figure it out from the performance profile. For example, imagine that you have a system that doesn't support hardware encryption. It's not supported on the chip by the CPU, so it's basically encrypting your data pages, and it's doing it in memory using the regular CPU. You will see that the encryption function will bubble up. It'll be one of the highest functions on the list. And you'll say, hey, you know what, maybe that's the reason why my database is so slow. Because I'm doing an encryption, my CPU doesn't support it, and I'm doing everything, computationally in memory, and it's not efficient. So those are the examples of when you would use DB2 performance trace. When you're searching DB2 trace, it's similar to searching for a parse. So you will look for return code, 1032. Also, when you have a DB2 Diag.log entry, and you want to match it with a corresponding trace entry, it's fairly simple, because even the process or mechanism of writing DB2 Diag.log entries is traced. That part is also traced. And you would look for functions or routines such as pdlog or sklt-log ZRC. And in the FMT file especially, you will see the exact same message present in the FMT file. The same message as the one in the DB2 Diag.log should be dumped somewhere in the FMT file. So that's a great way to narrow down exactly which place of DB2 trace you should be looking at. In some cases, especially when you're tracing a DB2 vendor process, or if DB2 is hung, you enable trace and the trace is empty. That's because in order for us to initiate tracing, we have to come across or stumble upon trace init points. And if your process is not doing anything, then it's not stumbling upon that trace init point. Normally, it would stumble upon it very frequently. It's, many times in DB2, there are places which basically reinitialize trace. But if it's hanging, or if it's a DB2 vendor process, it may not have come across that point. So in order to do that, in order to force that, you would issue a kill signal to DB2, and that will not kill anything. It will only initialize the trace facility for all EDUs that are currently registered with the instance. So it'll make sure that it'll do a forced jump to that place that initializes traces. Okay? So that's just an aside issue. Now, I've mentioned the manual ways of doing things, so OS level and all that stuff. If you're really not up to that challenge of remembering all of these commands, we have an easier way. We have DB2 FODC. DB2 FODC is a catch-all for all of the data collection that I've just mentioned. It does the stacks, it does the traces, it does the snapshots. In addition to that, it does it in such a way that IBM support and IBM technical people understand. We don't have to think twice about, hey, what's in this directory, what's in that directory, because we already know. We supply this tool, we understand this data well. So my suggestion is that if you're not familiar or not comfortable with using manual commands, use that DB2 FODC. And I know that many of you will probably have some comments on this, but I'll try to address them on the subsequent slides. So DB2 FODC stands for First Occurrence Data Collection. Some FODC happens automatically. You might remember that FODC trap or FODC index error, FODC panic directories. those are examples of automatic FODC invocation. FODC can also be invoked manually if you run that DB2 FODC command. The result, the product of an FODC invocation is an FODC package. So that's basically the directory containing that FODC underscore trap data, whatever. So that is the package that we are interested in. FODC consists of multiple components. One of the components is the executable itself, which is the entry point to this feature, which resides in SQL bin. But this executable is very dumb, I should say. It does nothing but it calls the engine, and the engine, based on the parameters to the executable, invokes one of these scripts. Now, these are all scripts: cause hang, cause perf, cause whatever, cause data corruption, cause trap. These are all core and shell scripts, or I should say shell scripts. And by default, they're located in SQL bin. And as a result, you can modify these scripts. You can add your own commands, or you can remove commands that are giving you trouble. And I always tell people that as opposed to coming up or discovering the wheel yourself, it's better to use what we have provided, the basic infrastructure, modify what we have if you don't like what we have, but use that DB2 FODC infrastructure if you can. So these are all the scripts, the callout scripts that will be executed by DB2 FODC. If you need to modify any of these, by definition, by default, you will not have access to SQL bin. You will, because its permissions are set to bin. So what you will do is you will copy the script that you want to modify from bin to ADM. And DB2 is designed in such a way that if there are duplicates, if there are two scripts and one of them is in bin and the other one is in ADM, the one in ADM takes precedence. The one in ADM will be executed first. Okay, so that's the first trick. So you can copy it to ADM, and then you, as the DB2 instance owner, will have access, modify access, write access to the file. Now, the second trick that I want to mention is, and that's a frequent complaint. People say, you know what, I run DB2 FODC-hang, and it takes 17 minutes or 13 minutes to execute. Okay, don't despair. There's a solution to this, and I probably will make sure that this is enabled by default. But inside the DB2 cause-hang script, there's a section that says no wait equals off. If you change no wait from off to no wait on, the script will finish in less than a minute. Now, why is that so? The no wait section, or the reason why the script is taking 17 minutes, for example, or 13 minutes, is because we have a lot of sleep times. We have a lot of iterations. We take one snapshot and sleep for a few seconds and then another snapshot. So these sleeps are pretty much what's consuming most of this time elapsed by DB2 FODC. If you switch no wait from off to on, all of these sleeps will be skipped. We will just ignore all the sleep states and we will exit in less than a minute. So keep that in mind. That's one of my favorite tricks as well. Here's the syntax for FODC. So there's DB2 FODC-hang or DB2 FODC-perf. There are other options, but these are my favorites. Each of these options, -hang, -perf, takes a sub-option, can be either basic or full. The difference between the two is basic will not connect to your database. Full will connect to your database. Obviously, when your database is hanging, you want to use basic. When your database connection is not hanging, you're still able to connect. Always use full because it collects a lot more data. Even if you use basic and DB2 FODC starts to hang as a result, we have some recovery states and we will recover from that problem. We'll try to collect as much as we can, but it's better if you know ahead of time, it's better to use the right option. There are some tricks on how to run FODC on a partition system, so you can refer to this later. The output, as I said, is an FODC package where the first word in that package and the directory name is FODC. The second word is symptom. The last word is timestamp. Here's the usual process of how the FODC package gets generated and then processed by DB2. So on your very left side, far left side, you have the DB2 engine, and something is happening in the DB2 engine. Either it's automatic or it's manual, so you're executing DB2 FODC hang or perf. So that will come to the DB2 costs, send that script, which will create that standardized FODC package. You can have a look at the package yourself, or you can use DB2 Support to collect all of this information. Then you send it to IBM, and we do FODC analysis. Again, we have some tools and methodologies to look at this data. We've also made some efforts to automate and data mine some of the information provided by our package. Do some learning. I'm a little bit hesitant to use the word machine learning because it's such an overused word these days. But yeah, there's definitely a lot of value in this information, and we have tried and we are actively pursuing better ways to process this information and come up with automated answers even before we call you back or even before we actually have a look at the data. So there's a lot of potential here, and hopefully that's going to be one of our goals for future. So the most common packages, FODC packages, are listed on this slide. The list is fairly up to date with regards to 11.1GA. I've extracted it from the source code. The only one that I believe is missing is FODC memory, mem outage or memfull. I forgot the actual name, which is a brand new FODC event that's been added recently in the recent fix specs. So I'm going to add this to the slide. The behavior FODC can be controlled or customized by the DB2 FODC variable. I'm not going to explain all of these options, but the most important one is probably dump core. That's what most people are interested in. Sometimes if they don't want to flood their file system with a huge core, they make a decision, hey, you know what, if there's an outage and should there be a core file, we're going to ignore the core file even at the expense of not being able to figure out the root cause, because flooding the file system is much more severe for us. So they will use the dump core sub-option of DB2 FODC to turn off core files or set a limit to core files. Okay, that's that for DB2 FODC. We're going to move on to DB2 PD or DB2 PD CFG. Now these are, as most of you are probably familiar with, those are command line tools that run completely outside of the engine. Even if the engine is dead or stuck, ill, I should say not dead, but ill, the DB2 PD commands will do nothing but they will connect to the shared memory that's being created by the engine, and they will interpret the data that's there, which is awesome because they don't need any latches, they don't need any runtime synchronization, they don't need anything. They just look at that shared memory and interpret that data that's there. So that's the good part. The caution part is as such, because they don't need any latching, they don't require latches. These commands or the output should be used with a grain of salt. For example, if you're looking at a lot of transient operations, let's say you have a lot of transactions that come and go, come and go, come and go, you might, in the same snapshot, see data for a transaction that does not exist anymore. So there might be a little bit of inconsistency in the data. But from my personal experience, I can tell you, and I use DB2 PD all the time, that if you know these limitations, they're no problem. Usually you can get the right information and the right answers just by using DB2 PD. The difference between these two is DB2 PD is for read-only operations. DB2 PD CFG shields or encapsulates all of the modifications to your engine. The difference, or the reason why we have two executables, is the second executable PD CFG needs an elevated level of database permissions. So if you want to change anything in the engine, make sure you have the privileges. That's the whole goal. Okay, there's also a tool called DSM Top, and every time I present this slide, people ask me, hey, what's the story about DB2 Top? Did you mean DB2 Top? No, I did not mean DB2 top. I purposely say DSM top because that's the future. And I do agree, and I do realize and do understand that many of you are used to the old DB2 top utility. I have to tell you that the DB2 top utility hasn't been maintained for years. If anything, the last fix that I remember personally is probably a few weeks ago when there was a leak, memory leak causing an instance outage. So we do fix such errors. But other than that, we don't maintain DB2 top at all. And it's really poor when it comes to partition systems or any kind of partitioning database or partition database environment. DB2 top will not produce reliable data. It's not designed for that type of a scenario. So DSM top, again, a tool shipped with the product. It's supposed to replace the deprecated DB2 top. I tried it in 10.5. I needed to install some Java libraries, so it wasn't really a smooth user experience. I tried it in version 11.1, absolutely zero problems. Things have improved significantly. I just ran DSM top and I got this output. So it's similar to DB2 top. Of course, you will probably argue that, hey, I'm used to a different format, different output. I just want to tell you that if anything, I would recommend to get used to DSM top because it uses the MonGet interface that's as fast as it gets, and it's designed to be producing consistent information in a partitioned environment, and it's the future for us. Now, once you have collected all of this data, the point is to bring the system back online. On Unix or Linux, typically, well, in order to bring a hanging system online, you have to kill the instance. How do I kill the instance? DB2 stop force will not work. It'll probably hang as well. So on Unix, Linux, I use DB2 kill. On Windows, I use DB2 nkill.exe. Okay. You can also do the regular kill commands and IPCS-A. This is all manual. I would suggest not to bother with the manual way. Just use DB2 kill. It will do all the cleanup for you. IPCS is, by the way, included into DB2 kill. So DB2 kill is a superset of IPCS. Don't just use IPCS. That's not enough. You also need to clean up the processes. So always use DB2 kill. If you cannot kill DB2, if you cannot get out of that hung state, problem solved. That actually means that the problem is not with DB2. That means that the instance is stuck in the kernel. And as such, it cannot be terminated. So it's an operating system problem. Most of the time when I see this behavior, again, from my experience, the problem is with some incompatible or new file system drivers that are loaded in the kernel. So you're using a top-of-the-line bleeding edge file system that may not be as stable as the regular standard file systems. So many times it's stuck, while waiting on I/O. And even if it's stuck in the kernel, there are still ways to get information from there. You can still use a kernel debugger and produce more information if you want. But that's just the next level. But anyway, the bottom line is if it's stuck here, it's the operating system. And the only way to get out of that state would be to reboot the operating system, unfortunately. Before you do so, make sure you open a ticket with your OS support. So that brings me to 125. And Scott, I think it's time for the second poll, please.
Okay. Next polling question, Q2. DB2 is not responsive. Connections are hanging. What is the best course of action? I like answer A. Blame a
I have to look it up. Yeah. Oh, okay.
Answer E is also
Blame a junior DB. It happens more often than you would believe. I have spoken to such people.
DB2 is not responsive. There are probably many organizations that would cry over that. Come on, we're trying to run a business here. So far, I'm going to let this go a couple more seconds. Go ahead and give us your answer out there, good-looking audience. Okay, we're going to close the poll and share the results. Uh, 43% B, narrow down the scope of the problem. C, take DB2 and operating system traces, 41%. Those two are almost tied. I'll bet one of those is your intended answer. Which is it?
So my intention was to go for B, narrow down the scope. Yes, B. B as in Bob. The reason for that is, let's compare it with answer C. Okay, take DB2 and operating system traces. At this point, you're making assumptions about where the problem is happening. So you're disregarding all of the top-down approach. You're thinking that, hey, it's probably somewhere in this instance. It's almost like a blind shot. A shot in the dark. So my preferred way, that's what I always teach, is before you collect targeted data, and DB2 trace and OS trace is a targeted piece of information. Before you go to that part, make sure that you are aiming at the right suspect. So that's why I always say, hey, narrow down, take your time, narrow down where the problem is happening, see if you can identify a specific EDU or a specific application, and then you can use DB2 trace and whatever traces and whatever tools you have towards that application.
Okay, well.
So thank you very much, Scott.
I see a question, I think. Let me see if we get to this question. Will running DB2 FODC-hang full stress the system?
That's a great question. Thank you for that. I'm not going to lie to you, it might. It might. If you have thousands of EDUs, then the part that will especially take time is DB2 PD-stack all, so collecting the call stacks. And I totally agree and understand people who claim that this is not acceptable. So if that is the case, then my suggestion would be to either comment out the DB2 PD-stack command from the FODC script, or modify it in such a way that it only collects information for EDUs that you are suspicious about. So if you already have a suspect, if you roughly know which EDUs might be causing the problem, try to direct that DB2 PD command to only collect specific information for those specific EDUs. If you're not sure, and if you know that DB2 PD-stack or whatever other command will just simply kill your system, comment it out. It's better to comment it out if you know it ahead of time. We, as IBM, we will get back to you. Maybe it will take us multiple iterations to collect the right data, but at least we will know what the pain point for you is, and we can even customize the script for you based on other information that we will find in the FODC package.
Okay, so one of our audience members comments then that they think both B and C are correct. Okay, another question: where can we get the information regarding internal function and RC codes generated in trace formatted output? Somebody's looking for the secret decoder ring.
I would say your favorite piratebay.org, wherever you can steal our source code from. Well, that was a joke, of course. Without access to our source code, you can't. And I have to be honest with you, I keep forgetting that number. Is it 100 million lines of code? Something like that in DB2. So even learning one component, learning it well to the greatest detail is a lifetime achievement. So each component has thousands and thousands of functions and function names and potentially return codes. We don't document these. your best bet is to go through our existing knowledge bases, such as Parse. We do have presence at Stack Overflow. We do have other ways like past forums and existing forums where DB2 problems are being discussed, and try to do your searches there. I have, however, seen or heard a similar request in the past, and I'm thinking of compiling the list of maybe top components and top functions, top return codes, and top latch names as a reference for you. So maybe watch for my future presentations and see if you can get your answer from there as well.
Excellent. We have approximately 8 minutes left according to the schedule, but like I said, we can go a little bit long if you need some extra time.
Okay.
And there's one more polling question. Let me know when you're ready for that.
Right. That should be at slide 154. So this is actually almost the end of the presentation. We'll probably need about 10 minutes over, give or take, but we'll see. Yeah. This is my first simulated hang exercise. So I'm doing connect to sample from session 2, from 2 different sessions. And then from session 3, I'm doing list active databases, and all of a sudden, actually all 3 commands are hanging. So I'm just doing a simple connect to, and everything is hanging. So this is a fabricated scenario, of course. DB2 never behaves like that, or shouldn't behave like that. But the purpose of this scenario is just to show you the basic technique on what to do. Okay. So you have 2 options. You can either collect everything, so you can do DB2 FODC-hang if you want, or you can do the manual interactive data collection as I have suggested on the previous slides. So let's take a look at FODC-hang. This is the output that you will see on your screen when you run DB2 FODC-hang. Now the sub option that I'm using is basic because I know that my connections are hanging. So you'll see some disclaimer. Several minutes later, you will see an output directory, FODC_hang_timestamp. Let's have a look at the directory. Inside that directory, you'll see a bunch of stag.txt files. Now these are the dumps for all the EDUs that I have. Obviously, my system is not very busy. I only have a handful, well, 10, 20 EDUs, so it's a breeze. It's very simple. Your case will probably be different. You will also notice that there are some subdirectories here, DB2 PD, DB2 snaps, DB2 trace, OSconfig, and so on and so forth. So that's exactly what I meant by saying that DB2 FODC is that simple. You just run it once, you let it collect everything that we as IBM need, and it should be, in most cases, it should cover our needs. Okay, now I'm showing you the output of analyze stack as we discussed on one of the previous slides. So I issued analyze stack against these 20 files or whatever, how many files we have. And I got stack analysis.out. And inside I see that 2 guys are waiting on SQL spinlock conflict. And 1 other guy is waiting on SQL spinlock conflict. Now at this point, you don't know what this function means or what it does. But at the end of this section, I have also included a cheat sheet with the list of important functions to watch for and functions to ignore. This is on the important list. Every time you see this one on a function from an important list, it means that the function has something to do with latching. It's trying to get a latch, acquire a shared resource. So this is something to watch for. So when you see spinlock conflict, it's a red flag. So we have 2 different EDUs competing here and 1 EDU competing here. That's as much as we can deduce or get from the stack analysis.out. There's actually 1 more guy that's kind of suspicious, that's completely different from the rest of the guys, and it's doing OSS sleep. And the rest of the instance is just completely idle. Okay, so let's just take note of that. Yeah, 2 guys competing about latches, 1 guy sleeping. Rest of the instance is just waiting for new requests like UOW waiting, that kind of style, where they're just waiting, EDUs are waiting for new requests to come. Okay, so we don't have access to our source code, so there's basically limited information as to what we can do. But let's put that information aside and let's have a look at the same information using a little different technique. Not exactly analyze stack, we already passed that, but let's take a look at the latch information in the individual files. So I'm in the FODC directory, I'm issuing grep-i latch type for all txt files, and I'm sorting that output. Latch type is a string that's common to holding latch type and waiting on latch type. So that's why I'm using this substring, and I'm just printing all the holders on all the waiters that are present in my stack files. So I can see that number 17 is holding database manager latch, and there are 2 iterations. That's why it's printed twice. So this is iteration 1, this is iteration 2. And then 26, 27, and 28 are waiting on DB-mgr latch. Is this the same latch as the holder is holding? Yes, because the name and the address are the same. So definitely, this guy is holding something that these green guys want. So in conclusion, we have 27 and 28 waiting for database manager latch, and it's stuck here. They're stuck here. And 26 waiting for the same database manager latch, which is stuck in start using local database. And then 17, if I may go back, is holding the latch. And if you look at the stack, this is that 17. So it's doing application local start. This is unmangled, by the way. This is not unmangled. This is the output that's slightly confusing, but it's application start using database, first connect, and then sleep. So this is the holder. It's sleeping while doing a first connect. That's all you can get. This is the end of our example. That's as far as you can get. Now the explanation for this behavior is that simple. First connect is a call that activates your database. So that's the first EDU trying to activate my database. While it's activating the database, it needs to log the database manager. It needs to acquire a certain latch. I have injected a code, fake, like ill code into the first connect function, which instead of returning from first connect is just sleeping forever while it's holding the latch. So 17 gets the database manager latch and goes to sleep. And as a result, 26, 27, and 28 just pile up behind 17. And this is the hang. That's the reason for the hang. Again, it's a fabricated scenario. I just used a modified version of Sleep DB2E, and I built it myself. So definitely, this is not something that you can reproduce in the product, in the shipped product. But this is just to demonstrate the fundamental approach, what you can do with the stack files and how you can look at the call stacks. Okay, here we have a simulated performance exercise. This one is slightly different. Select star from staff, takes about 5 seconds. So that's our baseline. And then we do some secret modifications, whatever it is. And all of a sudden, select star from staff takes 13 minutes, okay, as opposed to 5 seconds. So how do we proceed from here? So while the slow select is running, you can once again issue DB2 FODC-hang, but this time full because the database is connectable. Okay, sometime later you will get the FODC hang directory. And the first thing that I would look for is my favorite, VM snap. That would be in the OSS snaps subdirectory. And I will have determined that the run queue shows, yes, some non-zero running processes for sure. The block queue is consistently non-zero, so there's definitely some block processes waiting on I/O. And the I/O wait time is fairly high. It's like 27, 82, 84, 87%. We are definitely I/O bound. So whatever it is in the second command that's taking 13 minutes is doing a lot I/O. We can already conclude that just by looking at the VMstat snapshot, assuming that it's DB2, that's the root cause, of course. So the next thing is the DB2 snaps directory. I just like to compare them side by side. So here's a timestamp of 4:28 p.m. and here's 4:29 p.m. Put them side by side, and you will see that rows selected is increasing, but not too much. Rows read is increasing, but not too much. Rows fetched, it's like 10,000 over, and it's just yeah, there's a huge there's a steep jump over here. So there's definitely some reading going on. Yeah, well, actually, you know what? These numbers actually increased by roughly the same amount. So there's definitely 10,000 reads in between these two snapshots. Now we can have a look at a similar snapshot for the buffer pools. So the point here is that asynchronous data read requests over here goes through the roof. It goes by 40,000, 43,000. Basically, all of the buffer pool physical reads and asynchronous reads and all of those reads are going up. So in conclusion, there's definitely physical reads, there's buffer pool reads going on. And the next thing that I like to take a look at is DB2 PD/EDUs.txt. And especially since we're dealing with IO wait, I will look at the system time for all DB2 EDUs. Are there any EDUs that are completely outstanding? They're through the roof, much higher than any other EDUs in the system. And in this case, we got lucky. Yes, there are. There's prefetcher 54 and 53 that both of them have huge system time usage. So we have a suspect here. We have narrowed it down to potentially to 53 and 54 that for some reason are doing a lot more prefetch activity than in the good case. When we look at the call stacks, back to the call stack analysis that out for 53 and 54, we will see that these two guys are consistently stuck in readv, and SQL readv. Okay, so they're busy reading data from the disk. I'm telling you that they shouldn't be. Typically, data disk read is an expensive operation, but if you see a process that's constantly over and over again at any given point in time reading something from the disk, there's something weird about that guy. Either it's a huge table scan and none of that data is loaded into the buffer pool, or there's something ill about his behavior. So that's the call stacks. At this point, that pretty much concludes everything that we can do. So we know that two prefetchers are stuck in readv. We search, we could look for existing APARs. Again, this is a fabricated scenario, so it's just to demonstrate the basic technique. But that's essentially what you can get from that DB2 FODC-hang. If you, however, use DB2 FODC-perf, which is the other sub-option of DB2 FODC, you can get some additional information. I personally use -hang. I like it better because it collects more information, but -perf is a little bit more lightweight. We try to make a smart decision about which data we should collect, which call stacks, and we try to focus our data collection only on stuff that's currently active. However, the danger or disadvantage is that if this is a one-off situation, we may miss some of the data that we should have looked at. So I prefer to collect everything by DB2 FODC-hang. Anyways, DB2 FODC-perf, this is the perf package created by the script. And I would like to draw your attention to these two directories, DB2 perf count and stack trace, these two types of directories. So this is the profile for DB2, and these are the stack traces for selected EDUs. Looking at the profile, you can dump or sort the output using DB2 trace, perf fmt, and you will once again see the same information as we saw in DB2 FODC-hang. SQL readv and SQL readv low are very high. They're very high. They're consuming most of the time in the instance. You can already see that the danger or the problem with this data is that we don't know which EDUs are causing this. Okay, so again, that's just to demonstrate the difference between -perf and -hang. We don't know that it's prefetcher 53. We don't know it's prefetcher 54. You just know there's something readv going on. One more piece of information that I want to show you before we close is DB2 trace. What happens in the trace when you have a process that's doing a lot of reads? You will see something like this: readv entry, exit, readv entry, exit, readv entry, exit. I'll just be repeating and repeating all over again, all the time, never ending, never stopping. So that's the pattern to look for in your traces. Is there a huge pattern of reads or operations that seem to be never ending? Yes or no? In this case, in traces, we do see the thread ID, and we can actually match this or map this to prefetcher 53 or 54 by using DB2 PD-EDUs. Okay. So anyway, that's our conclusion. The real root cause is that, again, once I injected some custom-made code into the prefetching code path, and instead of doing one read the page once from the disk, I'm rereading the same page 10,000 times. So that's what's causing the extra time. So instead of one page read, I'm just discarding the page and reading again 10,000 times before I move on to the next page. So that's essentially what I did in my fabricated scenario. Now the last thing, and we're slightly over the time, I apologize for that, is a real life scenario for a hang exercise. So we have 9.7 GA again, connecting to sample, importing from data file, create index, create table, more commands, insert, insert, insert. The last insert hangs. Okay, so this is a real life scenario. So now we're presented with a hanging instance, and once again, we can use DB2 FODC, but in this example, I decided to do things manually and to go through the maybe more painful but more granular process of collecting my data interactively. So the first thing that I do is DB2 PD-stack all, make sure that I have stacks for all active EDUs, and I also take a look at DB2 PD latches. Latches shows no latch holders, no latch waiters. How is that possible? Let's double check. Let's do analyze stack-I and see what's there. Once again, from this point on, you will have to refer to my cheat sheet at the end of the presentation, but this is a red flag, that latch function. So there is a guy who's trying to get a latch, and it can't. How is that possible? There's no latch holders, no latch waiters. How come there's a guy who's trying to get a latch? There should be at least a waiter here, and presumably where there's a waiter, there should be a holder. So what's going on here? The answer lies in the function name. So in DB2, most latches are tracked, which means that we maintain latch tracking information for those latches, and we're able to find the waiter, find the holder. But there are a few exceptions. When there's a very performance-sensitive code path that it gets executed a million times a second, we can't afford slowing us down by doing some latch tracking. So there's a function called SQL latch no track, which basically means that, yeah, we are getting a latch, but unfortunately there's no time to track it. So this is completely invisible, it's completely hidden. Now the good news is that this call stack alone is very unique. It's some undo operation during row insert. So if you pick specific keywords from this, and if you know what commands you have done before the outage, at least you have a rough idea. You know, we were doing some insert, and all of a sudden we got a call stack with latch no track on top, and then IIDX underneath, and all of these. These are all good keywords to search for. So if you search for the keywords, you will actually find IC76907, DB2 agent hangs, and IDX for latch after it hits logs full situation. The actual reason, and you will learn that in the description, is that this guy is asking for a latch that it already owns. It's self-did latching. So some of the previous code path has already acquired this latch, and now I'm asking for it again, but I already have it. But I'm hanging because I'm waiting on a resource that I already own. So it's actually explained on this slide 151, which concludes my presentation. These are the cheat sheets that I've mentioned. So this is always, any of these routines are always a red flag. So always pay attention to any stack that has one of these routines in them. These are usually to be ignored. So typically they are indicative of a sleeping EDU, of something that needs or waits for another data to arrive from the user, another select command or another SQL command. So these are usually to be ignored. Not always, but that's a rough rule of thumb. And that brings me to the last poll question for Scott, and also my contact information. So Scott, let's do the last poll, please.
What is the difference between
that one is
investigating hangs and investigating performance issues?
Yes.
We are now asking, and people are responding. Okay, let's catch a couple more votes here, folks. What do you think? Y'all will be graded. Your graduation certificates depend on you getting this answer correct. Just kidding.
Did you say y'all?
Y'all will receive your graduation certificate.
I love it. I love it. That's why I picked on it.
Okay, here we go. Closing the poll, sharing the results. 51% said performance investigations may require additional data. I couldn't fit all the response that you gave me.
Right. That is correct. That's exactly what I was getting at. Yeah.
Okay.
So that's the second to last poll. I guess the last poll you can ask yourself, or it's really up to you. But my question for you, for the audience, is whether or not you have learned anything new.
Yep.
So I'll leave it up to Scott. Yep.
We always ask that one at the end. Go ahead and put your contact information slide up again.
Okay then. So in that case, I would like to thank everyone for participating in this session today. And I'm always very open to getting emails or in contact with Twitter or other means. So please don't be shy. If you need help, I'll try to help you. It's definitely always a pleasure to work with you guys, with the user of the product. As such, it does take me sometimes a few days or maybe a week to get back to you or to get my email sorted out. So please be patient with me. I would like to thank you, Scott, for organizing this excellent session and inviting me to speak to the audience today. And yeah, wish everybody a very nice weekend.
Well, you're very welcome. Thank you for being our guest. We're going to ask that last poll question now. I anticipate that everyone will have learned something, as much content as you provided. And replays will be available all summer long. You can stream them on YouTube now, download the files. Pavel, while you're thinking of it, shoot me a PDF of the presentation. Right
yes,
now.
I'll do it later this weekend because I need to clean up some of the formatting still in the speaker notes. So please bear with me, but I'll definitely send it as soon as I can.
Okay, well, I leave on vacation on Saturday for Italy, so.
Okay.
So people
I'll try
might
to get
have
it done today.
You're gonna have to escalate that for me.
Okay then.
So I can get it out to the audience.
All right, sounds good.
Closing the poll, sharing the results. 100% of today's audience learned something from you. Awesome.
Amazing. Thank you, everyone.
So watch the replays. We'll get the replay blog up soon. There's a post-show survey that you can do. Thank you, attendees. Thank you, Pavel. And hide poll results. Where am I not? Okay. There we go. Now you can see my screen. Good. Today's show was sponsored by DBI Software. Oops, don't do that, Scott. No. Smarter tools for smarter people, right? DBI is your trusted partner for breakthrough DB2 performance solutions that deliver invaluable results for organizations having the most demanding requirements and discriminating preferences. Absolutely. Watch your replays this summer. Have a fun summer and a safe summer. Stay out of trouble. Stay out of jail. And that's it. Have a good weekend, Pavel. I want to hear about that barbecue.
Thank you, Scott. You too. And I'm eagerly awaiting your steak recipe.
Right on. All right. Bye-bye.
Thank you again. Bye now. Take care.